This is the complete 4 hours long database design and modeling course you need as a beginner in 2026 because it covers both OLTP and OLAP data modeling in depth. And by the end of this course, you will design and build a complete OLTP database and then will use that to build a complete OLAP data warehouse, aka star schema from scratch. That means it's a complete end-to-end package. Moreover, this course is designed for those who like the practical way of learning. So in this course, you will actually learn the concepts by building and doing it. And more importantly, you will feel like you are sitting in the live classes because I will explain everything step by step with hand-drawn doodles and amazing real-world examples. I can confidently say that the complex topics and jargons like normalizations, ER diagrams, cardinalities, facts and dimension tables, slowly changing dimensions will feel like a piece of cake for you after completing this course. And if you are in the data domain, you would know that these concepts are so important for your interviews and for your day-to-day activities as well. And I have added one special section in this masterclass where you will learn how to use AI in your designing and building the data models because it is very important in 2020. So if you have decided to master database design and modeling this year to boost your data career, then just take out your notebook and pen and let's get started with this amazing masterclass.
So what's up, fam? Happy Sunday! And today we are going to master database design and modeling. And just for your kind information, this is a complete database design and modeling course. What does it mean? So basically, it will cover all of the pieces that you might need to learn, including OLTP layer or basically OLTP database design and modeling. And after building the OLTP database design and modeling, you need to learn how to create the OLAP modeling on top of this OLTP data modeling. So that is why I just call this as a complete end-to-end database design and modeling masterclass. So in this particular video course, you will learn everything by doing it. And let me just show you what exactly we'll build. So this is a kind of OLTP database that you will build. And after building this OLTP database, you will learn how to just use this OLTP database and model your OLAP database. And here you will just learn everything right from the requirement analysis and everything, literally everything. So I have just covered everything that you need to know for data modeling and designing. And here you will learn about normalization and then OLTP modeling and then facts and dimensions, star schema, slowly changing dimensions, OBT, everything. Basically all of the industry standards that we just follow in the data domain, especially for the database design and modeling. Simple. And yes, we are not using any paid softwares here. We are simply using the free software that you can just use for everything. Cool. The best thing that I personally like about this particular course is we have a lot of theory available on internet, especially on database designing and modeling, a lot. But in order to understand this thing, you have to use the doodles. You have to just understand the concepts using the live illustration. You have to just visualize the problems that are being solved by data modeling. Okay, data modeling is in demand. Okay, data modeling is being asked in the interviews, but why? What problems are being solved by data modeling? And what are the modern day problems? Because problems are also evolved, right? And yes, a special section is also focused on the AI part as well, like how you can just include AI in your database designing and modeling, how it can just play a major role in that. Obviously, AI does not take care of AI, this database design and modeling much, but there's a special layer which AI can automate fully. Okay, so we'll talk about that as well. So this is a very detailed section that I just decided to create. Why? Because if you would remember, if you would have seen that video, I created one data modeling which was focused only on the OLAP modeling last year, and I think 100k plus people took advantage of that video. So now more recently I was just getting the requests that please create the complete OLTP and OLAP design and modeling masterclass so that we can have a complete holistic approach. So I was like, why not? Because you like that way of learning data modeling. So now we have a complete course on database design and modeling. Makes sense because design and modeling go hand in hand. Cool, perfect. And obviously being a data professional, this is something that will actually boost your profile and will outshine you in the crowd. Simple. Very good. So if you have decided to master this concept, simply write database design and modeling in the comment section, or you can also write I love DDM, database design and modeling. and let's get started with this masterclass. So now, first thing first, why do we need database designing and modeling, and why, Ansh Lamba, it is so much important in the data domain, especially for data engineering? But this thing, as I've just mentioned, is for everyone. So let me just tell you one simple reason. So let's say you are working in an organization, okay, and this is your company. Now we know that this company would receive data from so many places, let's say from APIs, they would have some file server, they would have like literally so many things, right? They can have one application as well, let's say any application, anything, simple, cool. And as we know that for anything, we would need to collect some data, right? And all of these sources would write their data to a place, right? And as we all know, the most common storage solution that we have in the data domain is the database. So what will happen, all of these data sources would write data to a database. Okay, cool, no worries, so far so good. So let's bring very popular database, let's say PostgreSDB, but you can just imagine any database. Now this is cool, like we have the data stored in the database, everything looks fine so far, but Ansh Lamba, why do we need data modeling? Because we have data from the API, we have data from the servers, we have data from the application, we have data from literally everywhere for the company. We can store the data in the database directly. Why do we need to design a model? Why do we need to create the data modeling? Why it is so important? Why are you just adding so many difficulties to our job role? Okay, let me just tell you why. First of all, let's say you are dumping all of the data in the database. You can do that, right? But what will be the pros of it? It is very easy to just dump because you do not need to do any modeling at all. I know that, but it is not efficient bit because it creates something called as data redundancy. Why? See, let's say you are recording the data for the customers, okay, and they are just placing some orders. So let's say one time the person will look like this. Let's say the person name is Rohan and he ordered, let's say, XYZ thing. Then again he ordered something, let's say ABC. Then let's say he ordered something, let's say ZZZ. So why are you repeating this Rohan again and again? Why? Is it a good thing? Not at all. Not at all. And this is just a very basic example. So now the thing is, data redundancy is the problem because you are just increasing the data size and there's no reason behind it. You will say, Ansh Lamba, just tell us one thing. Even if we have data redundancy, what is the issue? That is a very good question, by the way. Even if we have data redundancy, what is the issue? We can work with data redundancy. We are fine with data redundancy. Why do we need data modeling? Why? Because I need to clear all of your whys before actually telling you what is data modeling. Okay, so that is a very good question, first of all. Now let me just tell you why. Storage cost is the one of the major issues. Storage cost. Are you serious? Ansh Lamba, today I was just using a database, okay, and I just checked the cost, the hosting cost, and it was costing around, let's say, 100 or 150 bucks a month for storing 1 terabyte of data. I agree. Let's say today you just want to store the data and you have, let's say, 1 terabyte of data, which is like very normal thing in today's era. So it would cost around 100 to 150 bucks easily. It's still fine. Okay, it's still fine. But do you know what? When we were introduced to data modeling, okay, this concept, this was the biggest problem. The cost, yes, storage cost. Because in 1980s, around that era, because when in around 1980s, data modeling was really popular, okay. So around 1980s, the cost for storing 1 terabyte of data was, any guesses? Let me just tell you, it was around 300 to 400 dollars. Not at all, $1 million. 300 to 400 million dollars just to store 1 terabyte of data. Oh my god, can you imagine? $300 to $400 million, not just dollars, $1 million. So this was one of the major issues of the data that we were just storing in the database. One of the major issues. Okay, what is that? Data redundancy. I hope you got it. Simple. This was the one of the major issues. Okay, data redundancy. Then after data redundancy, there were more issues as well. So let's say data redundancy is not a big problem in today's era, because now the storage cost is not that much high, but still we are performing data modeling because of so many reasons. Second thing is, you can say performance. When you are just storing and dumping all of the data, let's say in a single table, you can have, let's say, a table with hundreds of columns without any reason. So the query performance will obviously degrade even if you just want to, let's say, query a small set of data, right? Let's say data redundancy, and this thing is your data, or you can say performance, query performance. Cool. So this is your second thing. Okay. Now, if let's say we have a developer, let's call one developer, let's say this one. So this person used to query data from the database. Now, if this person will be querying the data from the database and he just wants to see, let's say, a few of columns, every time the query will just land on the table with hundreds of columns. Make sense? So why do we need to do this thing? If we can just have a very nice data model where we have small tables, where we have normalized tables, and do not worry, we'll just talk about normalize and everything, but you can just still imagine, because I know you are learning database designing and modeling, but still you would have a figure, or you can say diagram in your head about data model, right? So simple. So performance was the issue. Third major issue was scalability and maintenance. Okay, maintenance, I think A or E, whatever. So maintenance was the issue. Now, why do we need to maintain the data? I think E is there. I don't know, E or A. So maintenance. Now let's say a data will be frequently changing. Let's say this Rohan's surname is changed. Not after marriage, like usually changed normally. Okay. So let's say Rohan's surname is changed, or maybe there was a spelling typo. Okay. So there can be frequent changes in the database, and to be honest, in the database we have frequent changes a lot, right? So it is very difficult to just maintain that database where we do not have any kind of data modeling, because we do not have any kind of rules. Data can be inconsistent very easily. So these were the three major issues before data modeling. There can be some branches of this as well, let's say inconsistency and some rules and some failures. These will sum up under these major categories, which is data redundancy, performance, and maintenance. Okay, you can just keep on adding smaller branches, but these are the three major things. Then let's add some table here as well. Table, perfect, simple. So this was the third reason. Now you have got the answer that you need to solve this problem. Then obviously the subject matter experts of that era started thinking about it, how we can get rid of these problems. Then they just came up with a concept called data modeling. Okay, then they just came up with the concept data modeling. So let's talk about data modeling. But now you have a strong why, right? The goals that you are achieving with data modeling, the problems that you are solving with data modeling, because that is the most important thing. You need to know the problem that you are solving with data modeling. It is not like you need to learn data modeling because they are just asking in the interviews. Not at all. You need to understand it, because only then you will be able to work with it. Simple. That's it. You just need this kind of direction, and that's it. The rest of the things will be taken care by Ansh Lamba. Don't worry. Ansh Lamba will teach you everything. So now what is data modeling? Now some subject matter experts of that era who were working with SQL a lot, so they sat together. Okay, let's bring those people. Okay, so these were the three people, maybe more than that. So these people started talking about the best practices they can follow in the SQL area, right? Because obviously they still need to work with SQL database. So then they just came up with a concept called data model. This is the thing, data modeling. Oh, so now what is a data model in a nutshell? If you want to memorize the statement, you can just go on Google and you will find a very fancy statements. You can just remember and impress your interviewers. If you want to understand the thing, I would say data modeling is the technique to convert your data where you can have, let's say, very big messy table with no structure, nothing, very like poor looking data, okay, into a kind of organized structure. Are you getting my point? Converting your table into a nice structure, into a nice organized way, then you can call it as a data model. This is your process of data modeling. This is your data modeling in a nutshell. Okay, cool, simple. Yes. So whenever you want to create a nice organized structure for your data, and what type of data? Common sense, structured data, because data is in the form of rows and columns, but we still need to organize a more, you can say, organized way of storing the data. Data is still in the form of rows and columns. That is like common sense. Data is structured, but we do not want to just work with one single table with thousands of columns, millions of rows. No, we need to just segregate that data into nice structure, into nice organized manner. Simple. This is your data modeling. Make sense? And if anyone asks you, hey, what problem does it resolve? You know, redundancy and performance and I think maintenance. These three things. Okay. There is one more thing, like small thing, scalability, but scalability I put it under data redundancy because we are talking more about the cost and storage. So scalability is also part of this thing, right? And yes, remember this number. I was also like, what? $300 to $400 million just to store 1 terabyte of data? Wow. So this is your data modeling. Got it? Got the answer? Very good. Now, one follow-up question. I know. Ansh, Lamba, we have a table, like a very messy table. We understood it and we created the data model, right? But Ansh, Lamba, we have seen people talking about creating the, you can say, first of all, logic, and then just creating the tables, and we also need to write SQL statements to create the model. So what is going on? We actually do not understand what is like happening inside this particular area. Okay, very valid question. Let's talk about it. So basically, whenever we just talk about the data modeling is actually a kind of domain in itself. I would consider it as this thing. But domain, as we know, like are very, very wide. So we have put data modeling under data roles like data engineering, database admins, all of these things, right? But when we talk about data modeling, we have several, you can say, layers into this. So let's talk about layers of data modeling. Okay. Perfect. So your question was, Ansh, that we have this table, right? And we want to design something for our, or even if we do not have this table, we want to create a data model for our organization where we are storing the data, right? So now what we can do, even if we have this table or not, we do not need to worry about this thing so far. Okay. So among the layers of data modeling, the very first layer of the data modeling is conceptual layer. Okay, names can be different. Some people call it as business layer as well, but you need to understand the concept, because if you will read any book specifically, you may find different names because every person who would have written that book would be considering a specific name. But conceptual layer is a standard in the industry that we use. Cool. Okay, great. So now this is the conceptual layer. So now what is this conceptual layer? Let's talk about this thing. So whenever we just want to talk about conceptual layer, we mean to say that business. What kind of business? Let's say business, let's say any kind of logic that is built by the business. Simple. Any logic that is built by the business. So now what will happen in the very first layer of data modeling? You, technical person, will not actually do anything. Oh yeah, you will not be actually doing anything. Here in this particular layer, subject matter expert, or in some cases it can be team lead as well, So what will happen here? A team lead, let's say this is a team lead. You can just imagine that this is a team lead. So this team lead will talk to the senior leadership, or you can say the stakeholders who will be using this data model or database, or who will be building reports on top of this data model. So this is a kind of conceptual layer, because this particular layer will involve some communication, like what exactly you need. And that is why you see you can see it anywhere, maybe on some blogs, on some documentation, that we have dedicated layers for the data modeling. Conceptual layer is responsible for sharing the requirements. Let's say you will simply say, hey, what do you want? Only then this person would know, okay, what exactly I need to do, or what exactly I need to tell my team members what to build, right? So this conceptual layer is very, very important, because here you will share the requirements. Simple, cool. And do not worry, we're gonna just discuss everything in detail, like how to do all of these things, but you first need to understand the stuff. Okay, so here you will exchange the requirements from the users, and you will obviously ask follow-up questions. And why I'm just telling you, because in some cases, if you are a senior person, you can also do this stuff, because here you would need a senior person who have, let's say, built some data models. And if you're working in startup, and then obviously like you can literally do anything, right? So this is your conceptual layer, where you have to talk to the stakeholders. Very good. Now, once the conceptual layer is built, that means you have got some requirements. Your you can say high level overview is done about the data model. Then you will build something called as logical layer. What is this logical layer? Logical layer is the technical layer. Okay, because in the first layer, it is all about requirements, it is all about communication. In the logical layer, you build the logic. That is why it is called logical layer. It is a very easy way to remember this thing. What do I mean by logic? In case of data modeling, if you have heard about the term called entity relationship, if you have heard about it, if not, it's fine, because we're gonna learn everything in this. If you have heard about this thing, then it's a better thing for you for this particular section, just for this particular section. Entity relationship. So in the logical layer, we build a kind of ER diagram, or basically entity relationship, where we do what? Let me just show you. So what we will do, we will simply say, hey, according to the requirements, we have very clear understanding that we want a table. Let's say this is one table, and this table name will be, let's say, users. And this users table will have, let's say, some columns. For example, it can have user ID, it can have user email, all of these things, right? So we have this understanding. When we have this kind of understanding, we call it as a logical layer. Make sense? Logical layer. And we can have multiple tables, obviously, let's say orders, and here we have order ID, let's say order ID, and here I can say order amount, whatever, right? So I have this kind of thing, and I can also have a kind of relationship, kind of. So this is a kind of logical layer where we have the logic for the data model, where we have tables, where we have identified the tables, where we have identified the columns, where we have identified the logic to combine those columns, or basically tables via columns, right? So this is the logical layer. This is that layer that you see a lot everywhere in the documentations and the blogs, where you see a nice graphical representation of your data model. This is that layer, and this is one of the most important layer, because whenever you, or let's say anyone, would be working on any table, maybe you are querying something, you have to refer to the logical layer. Why? Because let's say you have joined a new organization, you wouldn't know like how you gonna join users table with orders table, right? You need the logic how these two tables will be connected. So in that particular scenario, you will ask, or you can ask the senior people, like hey, where's the logical layer, where's the ER diagram, where's all of these things? Make sense? Now the third layer, the most important, or you can say the most technical layer, where you write the SQL statements, it is called physical layer. Physical layer means the implementation layer. Here you actually implement the ER diagram. So what you will do, you will take this ER diagram, right? And you will use it as your reference point. Cool. Okay, this is your reference point. And out of this particular ER diagram, you will write, let's say, some SQL scripts. These will be your SQL scripts. Here you will perform, let's say, create table, all of these common SQL statements that we write, create table, insert into all of those DDL commands, right? But why it is so much important? Because here in this layer, you do not just create tables, you create keys. Now some people can say, bro, we create keys in this particular layer as well. And some people will say, hey bro, what are keys? Do not worry. That is why I'm just keeping this particular section is like very high level, because it is actually very high level overview. So do not need to worry about that thing. Okay. So keep your questions with yourself for now. So here we simply write the SQL scripts, and here we write scripts, let's say something called as create, update, whatever we don't want to do. Right? And out of the SQL script, we will get the real database. We will get the real database where we have the tables, right? Where we can just query the things. Wow. So this time, this database will not be just, you can say, one messy table. This database will be a nice distributed tables in a nice organized manner. Now users can query this database, and this data model, if that data model is actually well built, this data model will take care of all of the problems that we faced in the first section, which was problems without data modeling. Are you getting my point? So this is the hierarchy. Very first layer is conceptual layer, where you share the requirements. Second layer is logical layer, where you build the entity relationship diagrams, the relations, the logic. Physical layer is the layer where you actually convert that ER diagram in the form of SQL statements, and you just create the database. Wow. And let me just tell you one thing, okay, because now we are just surrounded by AI, so you need to know this thing as well, because now we have AI available. So only two important layers are conceptual layer and logical layer. Physical layer is still important, but just for the review. We just review physical layer because we can automatically create the physical layer with AI. I will also show you how you can just do this thing, because we have started doing this thing in the organizations, because we need to just work with AI as well, just to boost up our productivity. But still, it is not like it will be finally created by the AI. We get it created by AI, any LLM, and then we review it. And then after reviewing it, we run the commands, because in this physical layer, we actually do not need to think. We just need to run the SQL commands, and that's it. And we can employ LLM in this particular layer very easily. We have amazing, great LLM models, right? So we will just learn about all of these things. So now I hope like this particular section is crystal clear. How do you see the layers, right? Cool. Now let's jump on to the next topic, which is very important. And this is the, you can say, the focus point of confusion. Wow. What is this thing? Types of data modeling. Okay. If you are in the data domain, you need to know both the types fully, completely. But people who are on the software engineering side, who are not on the database side, they just learn only one, and that too not very much in depth, because they just know how to create the data model, but they do not think of how they will be just querying the data. But yeah, so what are the two types that we have? The very first is OLTP. Okay, very fancy name. Yeah, OLTP. This is the very first type of our modeling. Cool. Yeah. So what is OLTP? OLTP stands for, let me just write it for you, online transactional processing. OLTP is very popular among all of the databases, because this is the very first, you can say, step towards data modeling. What does it mean? I mean to say, whenever we want to store the data in the databases, right, we always perform OLTP first of all. Once we have performed OLTP, that means online transactional processing, then we perform the second type of modeling, which is more popular among, you can say, only data engineers. But to be honest, data engineers need to know both, because if you know OLTP only, then you can construct your pipelines in a better way. If you just know OLAP, you still need to learn OLTP. So it is called online analytical processing. Now, one more thing, we call this OLTP as database modeling, and for OLAP, we consider it as data warehousing. Yes, there's a special word for OLAP. But yes, because it is a kind of type of modeling, then we can also consider it as online analytical processing, OLAP modeling. These are the two major types of data modeling. Cool. Let's try to understand the difference between both. It is very simple. So let's say we have one application. Okay. Why I'm just taking the example of application, because in most of the companies they would have an application, and I'm just talking about more on the product based company. So you can just consider any example. Okay. Why I'm not taking the you can say service based company, because see, for service based company we can still create the database. It is not very difficult, but in order to understand the database concept, it is always recommended to take the examples of product based companies, because this is how we learn better. Okay, just a good practice, but you can just imagine any database. So let's say this is our application, right? We know that this application will be used by the users. Okay, cool. So let's say users. Okay, now these users can, or let's take an example of Amazon. Very good example. Let's try to take that example, because you have used Amazon, obviously. So let's take that example. So now users will be just interacting with the application a lot of time, right? They can have, let's say, they can place the orders, they can just maybe put the orders in the wish list, they can scroll the orders, and they can also, let's say, cancel the orders, they can just track the orders, they can just do anything. And meanwhile, they can also insert some data by placing the order. They can also change their information, they can just change their addresses. There is so much, right? So everything will be recorded in the database. Where is the database? Here it is. So let's say SQL. Okay, so this will be attached to a SQL database. Cool. Now this database will be considered, or let's say modeling that you will be just performing with this database will be considered it as OLTP. And then let me just remove this one and let's put it under here. Yeah, perfect. So now why this will be considered as OLTP? Because as the name suggests, transactional processing. Here we need to perform transactions. Now what are transactions? Okay, what are transactions? Very good. So let's say you placed an order, that is a transaction. You cancelled the order, that is a transaction. You updated your name, that is a transaction. You let's say change your address, that is a transaction. Everything that you are dealing, everything that you are actually doing on the application, it is a transaction. You clicked on a product, you put it into the wish list, that is a transaction. Make sense? Cool, simple. So whenever we need to perform transactions on an application, because transactions are quick, these are very frequent. You can literally scroll through so many products right now. You can just search for so many categories. Everything is a transaction. So whenever we need fast and reliable processing, we go with OLTP. This is first point. Okay. Very fast and very frequent changes. Very fast. Cool. Okay. Now Ansh, Lamba. Okay, that we have this particular database. Okay, transactional database, or you can say operational database. Okay, same thing. Now let's say we are just changing this database frequently. Yeah. So what is the problem? The problem is you need fast update, you need fast write, you need fast data, you can say upsert means like update and insert. Okay, deletion as well sometimes. So you need fast transactions, fast, basically frequent updates, frequent changes, frequent writes, frequent deletes, and that's it. So you are more focused on just, you can say, performing DML operations more on the database. DML means data manipulation. You are manipulating the data. Make sense? So here speed matters of changing your database state. But when we have this OLTP database, online transactional processing, we are more inclined towards speed of writing the data, updating the data, everything. But now when we just talk about OLAP, online analytical processing, we are not actually worrying more about changing the data in the database. Wow. And let me just tell you how do we build this particular modeling. Okay, you first need to understand this concept very, very deeply. Only then you will understand the entire masterclass. Okay, this is the key, this is the heart, because this is the area where a lot of people actually feel confused. Okay, but you do not need to, because you are on this video, so you do not need to. So now what will happen, let's say this is my database which is built already, and this is an OLTP database, right? I will use this database, okay, here as my source. Cool. Then after using this database as a source, I will create my online analytical processing, and because we have a special name for this database and we call it as data warehouse. Are you getting my point? Wow. So this is your data warehouse. This is your destination. Now, for now, you can also consider it as a kind of database. Yes, it is just a database, but it differs with the goals. Okay. It differs with the goals. Here the goal is something else. Here users are first of all not the customers, not at all. Here the users are your companies, your organizations, people. Okay, let's say managers, let's say leaders, let's say CEOs, if you have any. So these are the people who will be interacting with these. Now they will not be changing your customers' data. They will not be changing their address. What they will be doing? What? They will be building reports. Very good. Let's say reports. So they need to, obviously CEO will not build the reports. Analyst will build the report. Any other person will build the report. But this data will be majorly used for reporting, or basically finding the insights. Is it clear? Cool. So this data will not be changed frequently, but there's a special catch. Whenever I want to retrieve the data, I will be retrieving thousands, or I would say not thousands, we are in the big data era, millions of records, bro, millions. So the data size here will be big. Data size is huge, not even big, huge. The retrieval, the amount of records that we are retrieving, huge. So we need a special compute, special kind of modeling for this particular purpose. First thing. Whereas on the OLTP side, we do not need to update millions of records together. No, most of the time, one record. Okay, most of the time, users change the name. Okay, one record. Update the one record. User place the order. Insert one record. One record at a time. One record at a time. Very few records, but speed is important. Here, the speed is fine. We can wait for a few seconds. It's fine. But we need to retrieve huge data in one go. Clear? Because if you have built any report, you literally write or basically create a kind of filter of date where you would just filter the data of the entire 10 years, of the entire decade. You are retrieving data for the last 10 years. You need compute, you need modeling for that. So there's a different approach for that. Are you getting my point? Very good. So this approach is your fundamental or a building block for your entire masterclass, and not even just for masterclass, for your future as well. Because once your these fundamentals are clear, you are good to just go with data modeling, because you might be reading some books, you might be taking some courses, you might be practicing data modeling in your job. You will be good with this particular concept. Cool? Simple? Very good. So in short, and finally, just to summarize, OLTP for your transactional processing, where we just need to quickly, as soon as possible, update the record, insert the record, delete the record immediately. And for OLAP, we use the database as our source in most of the time, but that is not just the only source. Why I have taken this particular approach? Because this is a standard that we just use to just compare OLTP and OLAP. Then we build a special kind of modeling within the same database. It can be same database, because earlier when we were introduced with the data, you can say warehousing concept, OLAP concept, we didn't have special compute engines for your OLAP. Now we have, I know, Snowflake, then obviously BigQuery we have now, but at that time we didn't have. So we were using the same SQL database. It can be MySQL, it can be PostgreSQL, but only the modeling technique or style was different. But the storage, storage, you can say, software or storage tool was same. Make sense? Very good. Good. Cool. So this is your OLTP versus OLAP, and I hope this has cleared your concept and built a very strong fundamental knowledge, right? So now let's talk about the most important phase. Now, what is this? So now we understood types of modeling, what is data modeling, everything. Now let's get started with the OLTP database modeling, and let's talk about it. OLTP modeling, because we first need to master OLTP modeling. Once you have mastered OLTP modeling, only then you will be able to understand OLAP modeling. Simple, because the concepts, relationships, normalization, denormalization, all of these things are important, first of all, for you to understand the OLAP modeling, right? Cool. So let's start with the OLTP modeling. Whenever we talk about OLTP modeling, in order to apply OLTP modeling, there are multiple phases. Okay, what are the phases? Let me just bring this particular heading just to, so I'm just preparing the notes for you as well in this particular thing, so you can actually use it for your purpose. Cool. Okay, cool. So let's talk about OLTP modeling. Perfect. Okay, cool. So now the thing is, in the OLTP modeling, we need to actually see how we can build a model. And we understood, Ansh, Lamba, that there are 3 layers: conceptual, logical, and physical layer. That means Ansh Lamba will be following these 3 layers. Very good. Yes, we'll be following these 3 layers. Now the very first step to actually build these 3 layers is the first step, which is requirement gathering. Okay, requirement gathering. Cool. So when I say requirement gathering, I mean to say the conceptual, or basically you can say business layer or conceptual layer. Okay, cool. So let's say requirement gathering. Now this sounds very simple, but please trust me, this is the most important and the most, you can say, error prone area. Let me just talk about, and I will also share some best practices in the industry, so that you can actually outshine in your interviews, or let's say in your company if you're already hired. Okay, so let's say you want to model a data. Okay, you create a data model. The first thing is, you are a technical person and your name is, what is your name? Let's say your name is, let's ask ChatGPT, give us a random name. Okay, give us a random name. Yeah, what? Arden. Okay, Arden. Okay, so this boy, this person is Arden. Okay, so this Arden is actually talking to the business. Okay, let's bring the stakeholders. So here are the business people. Now there can be some business people, there can be, let me just write it for you, there can be business folks, there can be SMEs for the domain. Let's say you are building the data model for the finance domain, you need some SMEs from that area, because they would be frequently working with the data model. Cool. SMEs, and there can be team leads, and there can be some technical developers, or let's say developers. Simple. And developers would include your report or BI analyst as well, so that is also good. Okay, cool. And if you are BI analyst, then obviously you are just doing the work for both the things. So there can be these people. Now the thing is, just imagine you need to be in the shoes of this Arden. Okay, now just imagine that you are actually talking to 3 to 4 people sitting in front of you, and you have just entered the room and you started talking about, okay, I am there for you to help you out for building the data model. You can just tell me the requirements and I will build it for you. Do you know what? They will literally tell you something that you wouldn't have imagined. They will say, yeah, we want to build the data model. Yeah, just build it. Bro, can you imagine? This is the requirement that you are getting in return. So now it's your responsibility to ask the questions. Now they are non-technical people. They do not know what exactly you are talking about or what exactly you need. You need to drill down and you need to keep on asking the question that what exactly you want to do. Because just think about the data model right now. Create the data model. What? What data model? Just tell me tables, just tell me columns. They do not know about tables, they do not know about columns, they do not know about what is integer, what is string, what is decimal, what is float. They do not know about this thing. How are you gonna just talk about those people? You cannot. So what is the solution? Then you will be asking some business problems. Okay, you will be saying, hey, okay, just tell me about the overall goal of the data model that you want to achieve, and what are the, you can say, KPIs you want to build for your dashboard. Because they know everything about dashboard, that they need, let's say, average running total, they need 30-day running total, they need average sales, they need KPIs. That's it. They just need KPIs and that's it. Start asking about KPIs. First thing, bro, note it down. These will be the core questions in the interviews. I am so sure about it. Data modeling interviews are not about, hey, what is primary key? Hey, what is foreign key? This is not about the case. They need people who have actually built data models, bro. You cannot say, I have built the data model and I just know what is primary key, what is foreign key, what is one-to-many relationship. Bro, if you have actually built the data model, you would know all of these things. Okay, so first of all, you need to just note it down. KPIs, okay, very good. Very good. The KPI is like a very first starting point for the conversation. Second thing is you need to look for these 3 things. What are these 3 things? Obviously they will give you some answer back in return. And now you need to ask some follow-up questions and you need to collect just these 3 things. And I'm just telling you about this thing from my experience. Subject. Okay. Second thing is characteristic. Third thing is relation. You need to just collect these 3 things from their answers. For example, you asked something, let me just change the color. Perfect. This is very important, bro. This is very, very important. So let's say you talked to those people and then you just need to find these 3 things: subject, characteristics and relation from their answer. Let's say they said, I want, or let's say users or customers, let's say customers is like easy word. Customers will have an email. First thing. Then they said there will be, or let's say customers can place orders. Okay, then orders can have different products. So you will keep on drilling down on these questions. You will ask these questions. Now the very first thing, subject is this one, customers. Cool, you found it. Here you just need to use your communication skills, okay, soft skills. Customers. Then email. What is email? Email is characteristic. Subject, customer, and what they will have? Email, characteristic. Relation, will have an email. This is your characteristic. Make sense? Okay, cool. Then second, customers is the subject. Okay, then orders is your characteristic. Then can place. Okay, then orders can have different products. So this way you will find the data model. Are you serious? Yes. Let me tell you how. Now, in most of the cases, subject will become table. Subject will become table. Here customers or whatever will become the table. Characteristics might become columns or become a different table in itself. What did I say? Can become the columns for the subjects and can become a different table as well. Customers will have an email. That means email is a characteristic. Okay, cool. Characteristic. Simple. Okay. Now this is a subject, right? This is a subject. Okay. This is a subject. Now subject, customers table will have email column. Wow. Second, this is the subject again. Okay. But here I can have orders column as well, but here I will pick orders as a table. Why? Because I can further break down my orders characteristic as well. Because order can have, let's say, product. See, orders can have products, and then order can have order amount. So if the characteristic can be further be broken down, then it will be treated as a table. But if my characteristic is a standalone or independent characteristic which cannot be further broken down according to the requirements, then it will become the column. These are not hard and set rules, bro. These rules are not actually, you can say, these are some standards. No, these are like directly coming from the experience. These are coming from the standards. And these things will actually make you outshine in the interviews if you are able to explain this thing. I'm so sure about it. Make sense? So here, this is also a characteristic, but when this characteristic becomes your broken down characteristic, I just call it as object. Okay, I just call it as object, but still it is a characteristic. But because it can be further be broken down as per the characteristics, overall characteristics, then it will become object. So subject and object will have tables. Characteristics will become the table columns. Subject, object, tables, characteristics, columns. Clear? Good. Then similarly in this thing, orders will become subject, products will become object, because products can have categories, price, name, whatever. Cool. Very good. Now what about Ansh Lamba relations? Relations will come after building the characteristics, subjects and objects. We will talk about relationship after that, because relationship is, let me just explain in brief for now. So let's say we have subject and object, right? So if I want to find the relations, so what I will do, I will ask a follow-up questions. Customers can place orders. I will say, can they place multiple orders or can they just place one order? Developers or SMEs or business folks will say they can place multiple orders. So when I will get the word multiple, can place multiple orders, then I will use this as my relation to join these tables. But this step comes at the end of your ER diagram. So that is why we do not need to touch this thing for now. Otherwise you will be like overwhelmed. Okay. Subject, object, characteristics, subject, object, characteristics, and these three things. That's it. Relation will come after that. Cool. This is your requirement gathering stage. This is the backbone of requirement gathering. Now, two things that I have also seen people are asked in the interviews. They can also say what are the two common practices of requirement gathering. There are basically two: waterfall, and the second one is your agile. They can this is like a very simple common sense question, but still they ask just to test if you have actually built a data model or just saying that you have built. So what are these two things, waterfall and agile? So basically whenever we build any data model, or you can say this requirement gathering phase, in some organization they follow waterfall, and I don't know why, because waterfall is not actually a good technique to build any data model. Because in waterfall what will happen, you will go step by step. So this will be your first, you can say, step for, let's say, talking to the business stakeholders, and that's it. Then you have to build it. You will build the ER diagram. Okay. Then because you have built the ER diagram, you will build the data model, final data model, and then business people will literally look at the final product. and they will say, hey, but you have built this thing. I don't want this thing. You have not taken care of this thing. Oh, I want this as well. So they will just look at the final product, which is not a good thing. Why? Because if you just like serving the end product, okay, first of all, it will take a lot of time to reach to this stage, and then you are saying you have just provided this thing which they do not like. Then they will say change everything. Then you have to go to the first step again. You have to ask some questions. Then you have to build ER diagram. Then you need to showcase the final product. It is not a good practice. Okay, then you just follow the agile. Agile is like cool. Agile is like where you can just talk to the stakeholder. You can involve stakeholders in the middle. So this runs like a loop, weekly loop, monthly loop. You would have heard about Scrum meetings. It is actually a SDLC approach, but we have in the database as well. Okay, because database modeling is not a, you can say, a piece of cake. We just build data models once in, let's say, 10 years. We do not touch our database models. Okay, so here you will just go like this. So you will build something, you will talk to the people, and then you will build, let's say, something, and then you will just include them. And if they do not like it, you will not like actually build the final product, but they can actually engage with you in any of the steps whenever you just want. And you can just make changes whenever you just want in the cycle. Simple. Agile approach is a kind of circular loop where you just involve the stakeholders with small improvements, small development, and you do not just show them the final product, ta-da, and they will like, bro, what you have built, I do not want this thing. Then you can just follow the agile, and agile is the very good standard that we follow. This is all about requirement gathering. I hope this is clear. Very good. Now, because we have discussed about requirement gathering, now we need to just take a real world, real time example. So here because we are just using Amazon example, let's take the example of online superstore where we need to build the database for the online superstore. Okay, and we can just name it anything, and here we will be just working with that particular data model. And here let me just put very good, you can say, requirement gathering that we have got. I can write some English statements that we can just use, and after that we will be having a very crystal clear you can say data available that we need to just use for our data model. Make sense? Let's see that as well. So these are my requirements after talking to the business stakeholders, and then obviously as per the rules that I have just told you, subject and characteristics, subject and object, whatever. So for example, the first requirement is the system should store information about the customers who purchase from the company. Simple. So here the subject is customer and characteristics are information, customer ID, just the key, first name, last name, email, phone number, date joined. So far we have got these informations. Then you can talk to the business again. Hey, these are the characteristics. Do you want to add more? So then they can say yes or no. If no, then it's fine. If yes, they can just tell you more of the characteristics. That's how you just create the requirements and converting the requirements into a technical requirement that you or technical people can understand. Simple. And similarly, requirement 2, where we have information about products. Products and characteristics are name, category ID, price, and so many things. Then we have one more requirement, which is order processing. That means orders, whatever orders are being placed, right? And here we have subject and characteristics and relationship as well, but we do not need to worry about relationship for now. But because I had to just fetch out the information from the requirements, so I just put it here. Simple. Then requirement 4 is about store branch management, where we can have information about store branches and all. Simple. And then we have requirement 5, where we have payment management, like what will be the payment method, payment amount, payment status, all of these things. And then at last, shipment tracking. So these are the 6 requirements that I have got, and I have then converted into the technical requirements. So far so good. Very good. So once our logical, or basically the conceptual layer is done, then we need to go on the logical layer. Now logical layer, yes, is the heart of the entire data modeling, where you will be introduced to so many new concepts. But yes, it is a time to talk about that as well. Simple. So this is all about your very first layer, which is the requirement gathering. I hope it makes sense. And now talk about the logical layer, ER, entity relationship diagram, or you can say architecture, but you still need to just focus on so many things. Okay, first of all, so here what I just told you, We take the requirements and then we just convert it into the form of ER diagram, but we do not do it directly. There are so many steps involved in this particular layer. Yes, and you need to perform all of these steps step by step and carefully. Okay, first of all, you will convert RG, which is your requirement gathering, into the form of entities. Very first thing, entity. Now, what is an entity? What is an entity? Entity is basically, again, you can just learn the fancy definitions, but entity is basically fulfilling the one specific goal. If we are talking about, or I treat entities as theme. If we are talking about customers, there should be an entity for customers. If we are talking about, let's say, orders, there should be an entity for orders. If we are talking about payments, there should be an entity for payments. Okay. So in this particular step, you will convert all of these requirements into the entities, or just for the simple, you can say, understanding, you need to convert the requirement gatherings into the form of tables. Simple. In logical layer, we just call it as entity, but when we just, you can say, create the, or you can say implement that entity, it becomes table. In most of the cases, not in every case, but yeah, makes sense. So this is your logical layer. Now, because we have the, you can say, requirements, so how I can just create the entities. Okay, so now I know that I need to create the tables. Okay, so let's start creating the tables. Only then we will just understand the things. So let's say, first of all, I want to create the table. So first of all, I can create the table for customers, because we have customers requirement, right? So this will become one entity. Very good. Second will become orders. Okay, then third will become, I would say, payments. Cool. So these three are done. Now I will create products. Okay, let's say products, and all the information is here. Okay, on the basis of this thing. Cool. Now these four are done: customers, orders, payments, and products. What do we have else? Then we can have shipment tracking. So one is for shipment for sure. Payment management, we have done it. Branch, we can just store it inside the orders intentionally, because we will be just discussing this concept later on. So we will just put this thing in the orders, because this is related to the orders, store, branch, and whatever. Then order processing, this is done. Product catalog, products done. Customers are done. So okay, we have these tables. So 1 2 3 4. So now one table is for your shipment. So we have 5 tables. Simple. So for 5 tables. Now what exactly we need to do? I think we have one more. So far we have 5. Yeah, so 5 is done. Okay, 5 is good. So we have these 5 entities. Okay, these 5 entities. And what columns do we have inside this column, inside each entity? All the information is here in the requirement. That is why I told you that this is the, you can say, the most layer, because everything is now based on top of requirements. Now you do not need to think. Now you just need to implement. Okay, obviously you need to think a lot of things in this particular layer as well, but at least for this particular step, you do not need to think. You just need to write down all of the attributes, or you can say all of your characteristics. Okay, so let me just write it for you just to save time. So ta-da, we have all of the characteristics, or you can say attributes, for each entity: for customers, for orders, for payments, for products, and for the shipment. Cool. And yes, we have also put the IDs just to make the column, you can say, callable from the different tables, like customer ID. So in every table, we always create a identifier for that particular entire table. We will talk about these things later on, but this is like very simple thing. You can just digest right now as well. So whenever we create an entity, this is a standard practice that we always create a special column called ID. What is this ID? So ID means, have you ever used ID card for your college, for your university, right? Why? Because you say, hey, I am, what was his name? Arden? What was his name? I think Arden. Yeah. So that guy will say, I am Arden. So the guard will say, how can I just believe you that you are Arden? You will say, see my ID. This belongs to me. This is my identifier. So similarly, customer ID, order ID is a kind of identifier of that particular table. We just create these kind of IDs. You will know the reason later on, like why, because we will just talk about relationships, right? But yeah, you can just create the order ID, payment ID in each table. And why do we have created the customer ID as well in the orders ID? Remember the relationships? Remember relationships, that we have relationships as well based on the relationships. Cool. We want to discuss relationships in detail, trust me. Okay, so do not worry. I know like what thing, just like when to put what thing, so do not worry at all. So this is our entity, these are our entities, and we have all the columns, and yes, we have a special column which is called identifier column for each table: customer ID, order ID, payment ID, product ID, and blah blah ID. Simple. Now these entities are ready, really almost ready to be built. Okay, so now you need to open a special software. Okay, it is a free, I think, online software. Obviously it is free, but yeah, it is like very popular software. It's called Draw.io, where you can just build the data models for free of cost. You do not need to even subscribe to anything, no free trial. It is like a very common tool that every data modeler will use. Simply search Draw.io or draw.io. So this is the, you can say, online software that we can just use, and you can simply say start diagramming, or you can even download the desktop application if you want to practice it more and more. Good thing to have, right? Start diagram adding. Okay, so this is our canvas. Let me just use a white theme. It is like not very good. Cool, lights are turned on. So this is our Draw.io, basically canvas. So this is the area where we create the data models. Really, yeah, in the industries as well, this is like a very commonly used tool. But if you are using Microsoft set of tools, they have a Microsoft Visio, which is a very common tool for this purpose. But this is like free tool, you can just simply use it, and it's like very common thing. Okay, so what you need to do now, we need to create the data model, like nice structure that we just see in the you can say documentations, everything. So this is the time, because now what we are trying to achieve, we are literally trying to visualize everything that we have created, and we want to create the ER diagram, entity relationship diagram, which is the heart of everything, even for your interviews, even for your actual implementation, everything. Because ER diagrams has everything. It has all the logic, it has all the keys, it has everything, literally everything. Okay, so let's start doing it. So first of all, you need to land on this page. You can even rename it, let's say data model. This is very helpful if you want to save your files for your notes. You can just download it locally, and then you can just refer to it anytime, right? Good thing to have. Then you need to click on the entity relation tab here, because it will show you all of the necessary, you can say, objects that you might want to use in your canvas. Simple, you can even search it here, not a big deal, but this is like very handy. And here you just need to pick the object for the table. So here just hover over these things and you will find the very first icon as table. Click on this table and you will see the table here. Cool, you can increase the size as well, but that's fine for me. So I can just increase the size, like the window size. So now this is my table. Now first of all, I need to change the name. So first of all, I will create my table for, let's say, customers. Simple. Okay, this is my, yeah, customers. So perfect. And here first of all, I need to talk about primary key and all. We do not need to worry about primary key and all, so do not worry at all. Simply delete it as well. Yeah, we do not need to worry about primary key, whatever keys, we will talk about it later on. So first of all, we have, let's say, product ID. Then I have, let's say, customer ID, not product ID, customer ID. Let me just write customer ID, and then we have first name. Let me just open it in my window parallelly so that I can just quickly write it for you. Okay, cool. First name, last name, then email. And now if you are out of the spaces, okay, then you can even add the line as well, not a big deal. You can simply click on this box, okay, and then just go to arrange then go to table, and then just click on this particular button, insert row after, or I think above. So you can just pick after, you will just get one extra row. Simple. Okay, so just complete all of these entities, and then let's see what exactly we need to do. Okay, so these tables are created, and you can also change the colors if you want to. Just click on the table and then go to style, and then you can just change the color like this. Let's say this, whatever color you want to pick. Okay, cool. So these are my entities that we have created, where we have standalone independent entities, no relation, no keys, nothing, just entity. We have identified the entities and attributes. Attributes means columns or basically characteristics. We just have a special name called attributes whenever we just build the ER diagram. Okay, makes sense. Cool. So these are all of the entities. Now, one thing is optional here in the ER diagram, because I have seen in some cases, that's why I'm just telling you, it is not mandatory, it is optional. Some people also prefer to write the data type of each column as well in this particular ER diagram, but in the industry, I do not find it very, very useful, but I find it very useful sometimes because it gives us the idea, okay, what will be the data type, obviously. But it is not, you can say, mandatory thing. You can define the data type as well, because now I have used the word data type, I have to talk about it. Okay, let me just do it right now. So after creating, you can say, your entities, the next thing that we can just do is your define the data types. Okay, define the data types. Let's talk about the data types, because it is very, very important. It seems very, very easy, but when you are actually building something, you need to know the different data types available within your SQL database. Cool. Even if we do not write it in our ER diagram, we still document it somewhere. But I prefer keeping it in the ER diagram as well. It actually keeps it very transparent throughout the whole team. Okay, so the next thing that we have is your data types. Simple. Let's talk about it. So let's say data type. Data types means what will be the data type of each column, or basically each attribute. Customer ID, what data type you want to keep for this ID? Ansh, Lamba, something, because it will be numeric, right? Like it will be number. So if we want to keep the number, we have different options available. We have integer, we have big integer. So you need to pick the right one. If I just talk about the first name will also be in the textual format. So we have different formats, let's say character, var characters. So you need to understand the different data types of, you can say, different data types in the SQL. Simple. Let's talk about it. So the very first category of data types is numeric data types, where we store data in the form of numbers. Okay, cool. So when we have this type of data type, like any data where we require to store the data in the numeric format, then we just use either of these things. What the very popular one is integer. Okay, second popular is, I would say, big integer. There is one tiny or small int, but it is not very much used. These are the two most popular used for the normal numbers without any kind of points, without any kind of, these are basically the numbers that we simply say, let's say 10, 20, 30, minus 12, minus 30, minus 40. Integers. Okay, integers. So what is the difference between integer and big int? So the range of integer is approximately minus 2 billion to positive 2 billion. So if your number is in between minus 2 billion to 2 billion, we use integer. But if your range is in the, let's say, more than this, then you use big integer. Simple. Big int is very handy when you have, let's say, millions or you can say billions of records, because we use big int more on the OLAP side, but not in the OLTP side. But I cannot generalize this thing, because in some transaction databases I have seen like even more than billions of records, so it's fine. So if you have those, you can say big numbers, then obviously you can just use big integer, right? Very good. So this was just for the numbers without the points. But what if we have points as well? Let's say 10.5, 10.1, 20.3, whatever. For that, we have a special format called float. Float means when you just want to define a number like this, let's say 10.12, let's say, example. When you have some decimals as well, when you have some points as well, right? But here we have one more type, double. What is double? Okay, when we say double, okay, now what is the difference between float and double? So whenever we talk about double, this is basically the double precision floating point. It is also used for the points and numbers, but more accurate than float, because float is also approximate data integer and this double is also approximate data type. But when we use double precision, first of all we get the bigger range, second we also get, you can say, more approximation because it can handle the more number of digits, because you will not feel it when you have 10.12, 10.13, 10.14. When you have a number like this, like this, then you will feel the difference, and it can create a major difference when you are building the databases for the applications where you have to store the exact price. For any, you can say, applications that store the price, right? For any kind of, you can say, there are so many applications that store the price like this, like so big integers. And there's a, like, I think very popular story as well, when once exchange lost billions of dollars just because they were not storing the data accurately. There's like a very popular story on the, I think, west side, I think in the States or in the Canada, I do not remember it completely, but yeah, there was like very funny story. Obviously funny for me, but not funny for them. But yeah, okay. So this, when you have like in numbers like this, then you have to consider the double. And I can also open one quick comparison between double and float. Double versus float. Float and double are both floating point, that means point. Okay, float is a 32-bit single precision type, offering about 7 decimal digits. It's memory efficient, blah blah blah. But double is a 64-bit double precision type, provides around 15 to 16 decimal digits of accuracy. That means you can just store so many digits and still you will get the better accuracy. It is preferred for scientific computing, financial calculations, remember, okay, engineering applications. I can also find that incident, it is like very funny one, or you can also find it, it was like a big disaster. Okay, so this is all about our floating point and double. So let's say you have numbers like this, blah, blah, blah. Then you can just consider this double. Simple. There is one more, because see, float is also approximate data type, double is also approximate data type, but sometimes we have to accurately store the number. For that particular thing, we have something called as numeric. Numeric is very good. First of all, numeric comes like this with two parameters, P and S, where P stands for total number of digits and S stands for the numbers after decimals. So if I have, let's say, number like this, 10.123456 7 8 9, then my data type will become 1 2 3 4 5 6 7 8 9 10 11. This will become numeric. Okay, 11 comma 9, because there are 9 digits after the point. Makes sense? So this is like accurate. This is the exact storage that we just want to store. P is the total digits and S is the digits after decimal. This is very useful whenever you are just storing the currency exchanges. Obviously, because every single point makes a big difference, right? So these are all of the numeric data types. Now let's talk about some string data types. Okay, string data types, let's say string data types, because yes, we need to store the numbers, but at the same time we also need to store the characters, string, whatever, right? So there are 3, or I would say 4. Yeah, there are 4 major ones that we use. And yes, it is a standard of almost all of the data type databases, but in some databases they just use little bit different as well, but that is fine. So the first of all that we have is character. Now the good thing about the char or any kind of string data type is we always use, or sometimes most of the time we use a parameter of n. That means let's say I have to define char and then I will define the size of it as well. Okay. Now let's say I want to store the phone number. Okay. Now let's say I just want to store the phone number and I know like the total number of digits will be 10. Let's say. Then I can just use character. Now you will say, Ansh, Lamba, why are you not storing the number here? I can, but I'm just taking the example because I have the freedom just to pick any data type, right? So I can just pick the character for that particular purpose where I know the exact number of the characters. Now there's a brother of this character. It's called varchar. Here we also define the n, that means the size. But what is the difference? So let's say I defined character 10, right? And I stored something like this. Let's say Arden. Okay. How many alphabets do I have? 5. How much length I have defined here? 10. It will still take the size as 10. Oh, yeah, in memory, it will still take the size as 10. But if I define varchar 10, okay, varchar 10, if I write Arden, it will not take the size of 10. It will just take the size of 5. Then why do we define the varchar? Why do we define the size? Just a kind of upper limit. Up to n, up to 10. Oh, okay. It is also used for, let's say, email addresses. When you know like email address will not be longer than 100 characters or 200 characters. But it can obviously not exactly 200 characters. It can less than 200 characters as well. Simple. So you are simply setting the upper limit, but you are also saving some memory. Simple. So if your text is shorter and you know like I want to store something, a very good example is, let's say, country codes. When you know the country codes will be of the 2 alphabets. New York is a country. Bro, like codes, right? Like US, like Canada, CN, India, IN, like this. By the way, for Canada, it's CA. So like this. So we know that country codes are of 2 alphabets. Okay, so we can just store it like this and we can simply say character 2. So it makes sense here. But for varchar, we have full freedom and we simply set the upper limit. Very good. Now there is one more that I personally like is text. Because sometimes we need to store so much of data. Let's say you are storing the entire content of your file. Then you simply use text. Text means when you want to store a lot of data. Oh, okay. Yeah. It stores massive amount of textual data, blogs, you can say entire content of the file, everything. Cool. Very good. Now these three are the major ones. Now there is one more, nvarchar. What is this thing? This is very similar to varchar. Okay, very similar to varchar. But what is the difference? It is Unicode. What does it mean? So it is used for the international text containing non-English characters. Who is using non-English characters? There are some special characters which are not in, you can say, English dictionary, but still we just need to use it in our database. So we use nvarchar for that particular purpose. So it is called multi-byte character types. So it is for like, let's say when you are storing the data from entire globe. So it is for that particular purpose. So these are the major 4 ones, but yeah, you will be using these 3 ones most of the time, but you should know the nvarchar as well, because when you have special characters, we use nvarchar. Cool. Very cool. Then let's talk about the third one, which is date types. And these dates are very important. Yeah, very important. Why? Because there are so many formats. There are so many, you can say, data type versions of date. Okay, the first one is date itself. Yes, so it stores the date in the date format. Basically, when you have just date, let's say today is whatever date is today. What is the date today? I think, yeah, let's say 7th of June. So it will simply save like this, 2106, 06 and 06 or 7, like this. When you just have this information, date. When you have time, just time, then you can just save the time in hour, minute, second. So let's say 12, 12, 12, 12, 12, 12. Okay, like this. When you have, let's say, timestamp, let's say you want to save both. Okay, then you can just combine this one with this one, like this. So this is like complete timestamp. I hope it makes sense. Okay, there are like 1 to 2 more, but these are the 3 major ones that we use. So yes, and there I think there's one more, I think Boolean, but Boolean I don't know if it is available with all. Okay, so Boolean is there, and I think JSON B is also there for some databases. These are, you can say, some special data types which might have different names in the different databases, but these 3 are the major categories of your data types that you will be just working with them 80% of the time. But for 20%, you might need to search for your specific database. I think UUID is one of the data types which is not available in all of the databases. So that is why I do not want to put it here. So if you just want to find the database data type, you do not need to remember, you do not need to memorize it. You just need to go to the documentation or search in your Google or whatever LLM. Simply say, I want to find the data type for this particular database for this purpose, and you will get the type. But these are the major ones. You should know at least these things, right? So this is all about the data types, and I hope this thing is clear. Now we need to talk about the most important. Ansh, Lamba, everything is most important for you. Yeah. Yes. So now we're gonna talk about relationships. Relationships? No. First, let's talk about keys. Keys. Yeah. Keys is very important. And do you know what? This is the story of every data professional. They, or not just data professional, anyone who is just working with databases and data modeling. Keys is that concept that you need to understand, because anyone can ask you, hey, what is super key? You're like, super key? I just know about Superman, bro. So what is super key? What is candidate key? What is this key? So it's very easy to memorize the statements, but you need to understand the concept as well. Right? So let's try to uncover all of the major keys that we use in the database designing and modeling. Okay, let's see it. So now let's talk about the very first key and very popular key. Even if you do not know about this key, you would have heard the name of this key. This is so popular. This is called primary key. Everyone knows the definition of this key. A key that can uniquely identify the row. A key that can uniquely identify the record. Okay, but what does it mean, bro? What does it mean? Let me just tell you. So let's say you have a table. Okay, you have a table, and your table, let's take the example, like the normal example, because we do not need to take the example of our data. We can just take any example in order to understand the keys, because you need to see those keys, because these keys are not available in all of the tables. There is a specific criteria. So first of all, let's talk about the student table. Let's say we have the student table. Okay, and in the student table we are calling student ID as our primary key, and let's talk about why. First of all, primary key means in your table you should have one column which will have only and only unique values, whose values will never repeat. Column whose values will never repeat. If in this table you can see that student ID, it has 101, 102, 103, not even a single value of this column is repeating. So it uniquely identifies each record. That is why this is a very popular statement for this. What did I say? Unique. But Ansh, Lamba, if I just, let's say, put 100 records, start from 101 till 200. Okay, and if I insert one more record, and if I do not put any value inside it, and I just keep it as null, will that column will be treated as primary key? Not at all, because it has null. So there's a special condition. All the values should be unique, but at the same time it should not have any nulls. Simple, just 2 things. And you can, first of all, let's write it, uniquely identifies the record. Okay, and at the same time it has the property called unique and not null. Okay, not null. Third property is there can be only one primary key per table. You cannot say my table has 3 primary keys. No, only one primary key per table. Cool, very good, very good. Okay, this is your primary key. Simple, cool. Now this is very easy when you are just working with a table where you just have one you can say column where you just need to define the primary key, right? Okay, now I can have some cases where multiple columns can do this work for me. For example, let's talk about the second type of key, which is called candidate key. Candidate key. Perfect. What is candidate key? So now this primary key. So we had IDs like let's say student ID. Perfect. Okay, so I have student ID and I have let's say email, and then I have let's say name of student. So I have ID as let's say 101, and then I have email let's say ABC, and then name let's say we have blah blah, and then we have 102, then we have XYZ, then let's say something, then 103 and so on, right? So this is my table. Now just tell me one thing, what is a candidate key? What is a candidate key? Candidate key, first of all, what is candidate key? What is the definition of candidate key? Like what actually does a candidate key mean? Means like any column which can become primary key, which is actually a candidate to become the primary key. Oh, that is why it is called as candidate key. Now we know that whenever we want to create primary key, the goal is unique and not null. Unique and not null. Now tell me here, what are the columns which can actually do that work for me? The first column is this one, student ID. Yes, because it is uniquely identifying the records. But email is also unique, bro. See. So these two are candidates. Oh. So these two are the candidate keys. Because these two are actually the candidates for my primary key. These both can become the primary key. So these two are the candidate keys. Now there is one more key which is called alternate key. Alternate key. Now if we take the same example, let's say this example. Now you have the power. Okay, you are the judge. So you need to pick only one key, right? Because primary key can only have let's say one, like there can be only one primary key. You have to either pick student ID or email, right? So which one will you pick? Let's say you picked this time email. Let's say you have full power. You do not need to just pick ID every time. You can pick email as well. So this will become your primary key. Very good. But rest of the candidate keys will be called as alternate key. Oh, got that? Alternate key. Okay, so you picked this key as your primary key. So the next key, which is the remaining key, will become your alternate key. That means this is an alternative. Some people also call it as like alternative key, but it is alternate key. I hope it makes sense. Simple. Alternate key. That means you have multiple candidates, right? You have multiple candidates and you have picked only one. You have picked only one key, but rest of the columns will be considered as alternate keys, right? And all are candidates because all can uniquely identify the records. This is the concept. I hope it is clear. So now let's talk about super key. Wow, what is super key? What is super key? Anyone knows? Tell me in the comments. So super key, basically super key is like all of the possible combinations available in a table which actually uniquely identifies the record. Wow, Ansh, Lamba, what did you just say? Wait. So, for example, let me just explain this concept with the help of an example. So, first of all, let's say you have a table. Let's use this table. This is actually a very good example, and we can also extend it. So, let's say, let's have one more column so that you will have a better understanding. Cool. So, let's say I have one more column. Let's say phone. Yeah, phone is a good thing. Phone, and then I have, let's say, number 901, any arbitrary number, 189, okay? Then let's say 111. Simple. So now just tell me one thing. This phone can also uniquely identify the record? Yes. Agree? Very good. Now, super key means all of the possible combinations. All of the possible combinations. That means student ID is also super key. Student ID plus email is also super key. Student ID plus email plus name is also super key. Student ID plus email plus name and phone is also super key. Why? Because all of these combinations can actually uniquely identify the record. So how many keys do we have? Let's say first of all student ID, okay, then student ID plus email, okay, then another combination, then another combination, then another combination. Then the same thing will apply with the email as well. Email plus student ID and all of these things. Make sense? I hope it makes sense. So what is the purpose of super key? To be honest, in the practical world, nothing, but in from the, you can say, concepts point of view, it is very important. So super key means any possible combination of your you can say columns that can uniquely identify the record. So what do we say? Because this concept is very important from the interview point of view. Okay, that's why I'm just explaining this thing. So this is the, I would say, chart that would look like this. So this will, let's say, your super key. Super key means all of the possible combination. Okay, this is a super key. Cool. Now I know that my super key is student ID, email ID, phone. Student ID plus email plus name, like this, right? So let's say student ID, okay, student ID is primary key, simple, email, phone, or let's say candidate key, at least candidate key. Cool. So these three are good to go. Then student ID plus email, right, and so on. Now all of these IDs are super key. Candidate keys are those keys which have the least possible, or you can say least number of columns which can uniquely identify the record. So which columns are candidate keys? Student ID only, email ID only, phone only. Cool. So this will become your candidate keys. Okay, just understand this thing. This is very important. Candidate keys. That is why a lot of people suffer in the data modeling interviews, because this is like very complex. But do not worry, that's why I have created this masterclass just for you. Okay, just do not feel like this is very tough. Even if it is tough, don't worry, I'm here. Okay, so this, now the next circle is for your primary key. Now you know that we can have multiple candidate keys like student ID, email and phone, because these can uniquely identify the record. Plus these are the least possible combinations we can just use for the, you can say, unique record. But we only pick one primary key, right? So that is why I will simply say primary key. So this will become my primary key. I hope it makes sense. Primary key. Simple. This is your primary key. Super key means all of the possible combinations. Candidate key means all of the least possible number of columns that we can use for the primary key. That means candidates. And then finally the primary key. Make sense? Let's see if we have any good diagram available in the documentations. So let's say super key. Go to images. If we same. Because this is like a very common diagram whenever you just use to explain. So I think our explanation is good. We do not need anything else. Yeah, we are good. Simple. Cool. So this was awesome. So remember these things, combinations of all the possible columns that we can just use for uniquely identifying the record. Then we create the candidate keys. That means what? That means the least possible combination. The least possible combination. We need the minimum number of columns that we can just use to uniquely identify the record. All those columns will be candidates. Then we will pick only one column as primary key. Wow. Finally, you understood all of these major keys. But we have some more keys as well. But yes, we have one more key and it is called unique key. What is unique key? Unique key is a kind of primary key, but with one flexibility that unique key can have null value as well. Okay, that is the only difference between unique key and primary key. Simple. So let's say I have this table. Okay, now if I say email can have null, now this email cannot become primary key. No, because I have null value. But this email column can be considered as unique key because every value is unique. Simple. Oh, so that means one null value is allowed for unique key. Exactly. That is the only difference between unique key and primary key. Cool. Very good. Very good, very good, very good. Now the last key, which is the backbone for relationships. It is called foreign key. And do you know what? Listen to me. These concepts regarding keys, if you are finding it difficult, you are not the only one. Okay, every single person who has learned data modeling, who has understood data modeling, the person would be in your shoes. I'm telling you this thing. Okay, so you need to put some extra time. You need to rewatch this section of the video to better understand the concepts and retain it. Okay, you are not the only one. Do not feel like that you are not able to understand these concepts in one go. This is not magic. This is not like very easy thing. That is why companies are paying so much of salaries for these roles, because these roles are challenging. Okay, then let's talk about foreign key. What is foreign key? Any guesses? Any guesses? Foreign key that lives in foreign. Nice joke. This is not a joke. This is the reality. So what is foreign key? Foreign key means this is the key that lives in the foreign table. Okay. What does it mean? Let's take an example. For example, let's say we have an orders table. Okay. We do have orders table, right? Very good. So this is our orders table. And within this, we have orders ID, order ID. We have order amount or whatever quantity. We have order or let's say product ID, or let's say customer ID. It will be easy to understand. Customer ID. Simple. This is my table. Cool. Similarly, I have one customers table. Customers table. Oops. Okay, keep it like this. And then inside it, I have customer ID and then customer name. Then I have, let's say, email. Oops. Perfect. So these are the two tables. Let's use different color. Perfect. These are the two tables, right? Now what I will do, I will simply try to create primary key. What will be the primary key in orders table? Now you are well versed. Like you can guess. Okay, it will be order ID. Very good. Very good. This is my primary key. Here, primary key will be this one. Very good. Now I want to connect this table, this one, with your customers table. How I will just do it? I need a kind of relation. And yes, relation is the very next section. But before covering relation, you need to understand foreign key. Now you will say, Ansh, Lamba, I can see that customer ID is also in the orders table and it is also in the customers table as well. So can we use customer ID to join these two tables? Exactly. That's what we do. So here, this customer ID is what? Is the joining column, is the bridge between my orders table and customers table. So this key will become my foreign key. Wow. This will become my foreign key. Okay. But Ansh, Lamba, this is my foreign key in orders table. And this is my primary key in the main table. Exactly. That is why it is a definition as well, that foreign key in the child table is actually the primary key in the parent table. Let's use this font. This is better. Yeah. Makes sense? So remember this point. This is very important because foreign key is the foreign key in the child table. That means this particular thing, this foreign key always lives inside the child table. Here, what is the child table? This one, orders table. And the parent table is customers. Oh, so wherever we create the foreign key, that means that is a child table. Because these wordings are very important, bro. And we always, you can say, create a flow from child to parent like this. Foreign key always goes from child to parent. Okay. Simple. Now, do we need to have any rule on foreign key? Not at all. You do not need to have unique values. You do not need to have a property which will uniquely identify your record. Not at all. Because those are the constraints, those are the rules which will be obeyed by this table. Because we have primary key here. But when we create foreign key, we do not need to obey anything. But we just need to make sure that this ID is actually the parent key. It is actually the, you can say, primary key in the parent table. That is only the rule we need to obey, and that is it. Cool. This is your foreign key. Foreign key is actually a bridge to connect those tables. Simple. And rule number 2, foreign key always lives in the child table. Rule number 3, foreign key always flows from child table to parent table. 3 rules are clear. Very good. This is all about the keys that we have. Very good. Now there is one more special key that I want to talk about with the primary key, because now you are well versed with it so that you can easily understand it. In some tables, we can uniquely identify a record with only one column, and that works completely fine. For example, in the students table, we have student ID, right? But in some tables, let's say in some tables, we do not have one column that can uniquely identify the record. For example, very good example is, let's say, order items is a very good example where you have like multiple things. So student ID, or let's keep this example. So let's say student ID is this one. Okay. And one person can have multiple email IDs. This is the condition of the table. We can have any condition, right? It all depends upon the requirements. So one student can have multiple email IDs just for this particular demo. So what I will do, I will literally create 104 here, and then email will be different. Okay, email will be different. So when I say email will be different, now here in this particular block, I have to write something, let's say BBB, and name is same. Let's say NVN, NVN. So this is the same person, 103, but this person has 2 email IDs. So now just tell me one thing. So this will also be 103, by the way. Perfect. Now just tell me one thing. But I think if I just pick different email, then I can just pick email as a primary key. Okay, let's change something. Let's change the plan. Okay, I got it. So let's say email is also same. But this person has 2 names. Oh, why? Nickname. I don't know, because we just need to mimic it. So let's say NVN and this name is MVM. Okay, this person can have two names, maybe nickname. We are just using nickname in the school. Okay, so this person can have multiple names. Now, just tell me one thing. Do we have any kind of, you can say, primary key here? No. Student ID is not unique. Email is not unique. Name is not unique. But what if I tell you that if I combine student ID and name, it becomes unique? See, 101 and blah blah blah, unique. 102 BDALF, unique. 103 NVN, unique. 103 MVM, unique. When I can just combine these two columns, this will become unique. Yes or no? Yes. So that is the concept of something called as composite primary key. This is a special case of primary key when we do not have single column which can uniquely identify a record. So that's why we call it as composite key or composite primary key. Interviewer can just trick you by not adding the word composite primary key. The person would just say composite key just to trick you, but this is the same thing. Cool. This is a special case of primary key, but yeah, goal is still the same. We need to uniquely identify the record. Clear? Now here comes my favorite topic, relationships. So in database, okay. Now we need to understand how we can just create relationships in the databases. Okay. Now the thing is, in order to create relationships between the tables, between the entities, remember our data diagram? Let me just bring it here. Where is our data diagram? What is this thing? Oh, I just changed the look of my. Okay, it's fine. So yeah, these are our entities. Okay, we still need to complete it with the relations, right? But before doing it, can we are we in the good position just to mark the primary keys and all? Can we? Very good, but not completely, because when you understand the relationships, then you can only mark the primary keys and foreign keys, because you can still mark the primary keys. It is very simple. You can simply write, let's say, primary key here, because primary key is sorted. But in order to mark the foreign keys, you need to first understand which table will be connected with which table, right? So let me just add primary key everywhere. So these are our primary keys, but we will not add foreign key here. So now I need to connect these entities with some rules, with some, you can say, things that we need to configure. Let's unfold this thing. So whenever we need to connect different entities, we need relationships, right? So how we can configure relationships? In order to do relationships, in order to perform relationships, we use something called as cardinality. Let's talk about it. Cardinality. Perfect. Cardinality. Cardinality means, basically there are three types of cardinality: 0, 1 and many, and that's it. 0, 1 and many. Okay. 0. Let's use this font. I think this is better. Yeah. 0. Then we have 1. Then we have many. These are the cardinality. Like, I will just complete it because we have completion like 1 to 1, 1 to many. But these are the three major types, or you can say three major things that we use with cardinality. When we say 0, we use a special notation. It's called, there are like two different kinds of notation, but do not worry about notation right now. Just follow what I'm saying right now. Okay. So there's a special notation like this. So let's say whenever we just want to refer to the 0 notation, we say like this. Let me just color it. It is this one. Okay. This is a 0. That means O, 0. When we just want to say 1, oops. When we just want to say 1, then we simply create a line. Let's say like this. This is 1. When we need to say many, then we simply say like this. Like this. This is your many. Okay. Sorted. Very good. So this is all about your 0, 1 and many. These are the cardinalities that we have. Cool. Now we use these cardinalities to define the flow of your data between the entities. Cool. Let's actually try to see that thing. For example, For example, let's use our own example. So we have some entities. Let's take some, let's say customers and orders. Okay, let's take these two entities. So we have one entity, let's say orders. Okay, so we have this orders entity and we have one customers entity. Cool. Now just tell me one thing, how these two entities will be connected. Let me just tell you, it's very simple, but this is very important. Okay, now you cannot say that orders will be connected to customers with one type of relationship. No, no, we also need to define the flow. So when data will be flowing from orders to customers like this, then we need to talk about what is the relationship. Okay, and we define relationships using these cardinalities. When data is flowing, or basically data is going from orders to customers, how is the flow? Let me just expand it. Can one order have multiple customers? Can one order, like one record of orders table here, can have multiple matchings for customers? Obviously no. Obviously no. If you have placed the order, only you have the place, only you have placed the order. You cannot say like the same order ID is connected to multiple customers. That means when I am connecting orders entity, only one record is available on the customer side to map. Is it true? Right? Very good. So maximum numbers for the orders. Let's use this line to connect it. So maximum number of records that can map to one order ID is 1. Very good. So that is your 1. Cool. What is the minimum number of orders that can match? Obviously 1. Why? Because obviously if order is placed, that means someone has placed the order. Okay, 1. So this is your outer. This is your outer. Let me use this one. This is your outer, and that means maximum mappings, maximum match. Okay. Outer is your maximum match and inner is your minimum match. Simple. Nothing difficult. Maximum and minimum match. Okay. This is the minimum. Inner one is minimum. Remember this thing. Cool. So maximum is 1 and minimum is also 1. Now let's talk about customers. One customer ID, if I take one customer ID, okay, how many orders can I find for one customer? So many. One customer can place so many orders. That means I will be having this thing. So many. Perfect. This is the maximum. Okay. Maximum. And how, like, what is the least number of orders that a customer can create? 0. Obviously 0. Maybe order is registered with the application, but customer has still not placed any order. So minimum number is 0. That is it. This is your relationship. Now when I talk about relationship from orders to customers, it is 1-to-1, because you always talk about the opposite thing. When I say about orders to customers, so I will look at this area. Okay, at the front, I always look at the front. Remember this rule. If I'm saying orders to customers, I need to look at the customer side and I need to just stand on the order side. So relationship is 1-to-1. Okay. If I say relationship from customers to orders, it is what? Customers to orders. So it is your orders to customers. So 1 to many. So many side is here and then 1 is here. Is it clear? So this is your 1-to-1 when you are talking about orders to customers, and when you're just talking about customers to orders, it is many to 1. Some people try to keep it simple with this notation, because you can have wordplay as well. Let me just explain. I will simply say how many records can I find for this customer's ID into this orders table. You can feel confused. So that is why we use this kind of notation. We do not say what is the you can say relationship between orders to customers when data is flowing from orders to customers. We do not just say like this. It is not like actually reliable. Okay, because you cannot just keep on talking about flow, which direction you're talking about. That is why we do not talk about this thing. We simply say this is the notation. If you just want to check the flow, you can simply say there can be multiple orders for the one customer, and one customer can have multiple orders. They can simply check the direction wherever they want to just check. Simple. We do not say, hey, what is the direction of this. We do not do this thing. And this notation is called crowfoot, which is my favorite. There's one more, I think, Chen's notation. I do not like it. Chen's notation, like, it is so ugly, and this that makes our data model so ugly, and it is so hard to read and deploy that create the data model. It is so ugly. Let me show you. Crowfoot versus Chen's. Crowfoot versus Chen. So do we have any image? Yeah, so this is your Chen model. This is your Chen model. They just create entity in the square, and they just define all the attributes in the circle, and they just create, I think, diamond for the relation. This is so ugly, man. This is so ugly. And let me just tell you, in the industry, we use crowfoot. So if you're learning crowfoot, you are good. You do not even need to learn about Chen model. Do not worry at all. Do not worry at all. And you need to be confident whenever someone tries to just, let's say, put you in that situation. Hey, you do not know Chen's model? I don't need to learn, bro. I do not need to learn. I need to build data model. I am building the data models for the industry, and I know the standards, and that's it. I am happy with my crowfoot model. Okay, that's it. Simple. Simple. So this is your crowfoot or crowfoot, whatever you just want to say. So this is the notation that we are just simply using. Did you understand this particular thing? Very good. This way you need to create all of the relationships. Make sense? Okay, very good. So this was a very good example of relationship called one to many or many to one, like whichever way you just want to use. Okay, so now let's see a very good example of other things as well. Okay, like what are the cardinalities that we can just use. So similar to this was a very good example of one to many or many to one. Simple. So now similarly, we can have similar thing for other relationships as well. So this is, let's say, many to one example. When we have one to one example, in one to one, what will happen? This side will also be having just one record for both the things. Okay. Very good example is department and manager. Because one manager will be the manager of only one department. Common sense. Right? So this is the example of one to one. When you have only one record from both the sides. This is the second type. So one to one is good, one to many or many to one is good. Now let's talk about the most critical one and the most messiest one, which is called many to many. Many to many. What is a like common example of it? First of all, orders, okay, and products. Cool. Now just tell me one thing. Can one order, if you just place any order, okay, can one order have multiple products? Obviously, you can place so many orders, like you can place so many products in one order. Agree? Very good. So this is many. That means multiple products can be there maximum. And what is the minimum number of products that I just use? I would say one, at least one. At least one. Okay. Now, one product can be ordered by so many orders. Like you ordered, let's say, iPhone 15. Someone else can also order iPhone 15. Common sense. So this will also become this thing. Many to basically many. Okay. And how many things do we have here? There should be like one product at least. So this will become your situation of many to many. Ansh, Lamba, this looks cool. What is the issue? The issue is, let me just tell you. Actually, many to many is the combination of two things, many to one and many to one. Let me just tell you. When I talk about orders to products, okay, this becomes like orders to products. That means one order can have multiple products. That means one to many. Okay. Then when I just talk about products to orders, one product can be ordered by so many orders, so many to one. So this is actually the case of many to many, but because now we are talking about both the sides, then it becomes many to many. Oh, so what is the issue? What is the issue? Okay, we understood it. What is the issue? The issue is we cannot create this thing in the data model. Why? Why? See, it, like, come here. So let's say you have this table orders. Try to populate the data. Okay, let's say order ID, and I have product ID. Yes, order ID is my primary key. Okay, so I will say 1, 2, 3, 4. Perfect. Let's say I ordered product, let's say 101, and then I ordered 101 again. Then I, let's say, ordered 103, and then let's say I ordered two products in the order ID 4. So I ordered 101, and in the order, same order, I ordered one more product, 102. So now tell me, what is the primary key and what is the foreign key? Oh, because we cannot have primary key here then. Exactly. Because obviously in the products table, I will be having something like this: product ID 101, 102, 103, 104, and 105. Simple. So that is good. That is good. But see, this is messed up. So that is why we cannot actually implement many to many in the database. We can have it in ER diagram, that is good, but we cannot implement it. So that is why we create a bridge between these two entities whenever we have the situation of many to many. So here I will introduce one more entity, and this entity will be called as order items. Oh, so this is a bridge. Okay, this is the bridge, order items, and let me just correct it. Yeah, this is cool. Perfect. Order items. So now what will happen? This is my new table, order items, new entity. I have to introduce it, otherwise it will not work. It is not like I am introducing it. It is like the rules of SQL database modeling. Okay. So here what we need to do now, we do not need to connect order ID directly with the products ID. Not at all. Now we have this bridge. Now we will connect our orders table to this order items first of all, and we can connect our products table to this particular order items. So whenever we want to combine orders with products, we first combine it with order items, and order items will be connected with the products table. Simple. This is a bridge. What is so special in this bridge? This has nothing. This will simply have the IDs of both the tables. So order item table will look like this. So it will have column like this, let's say order ID and product ID. And here it will use the composite primary key. Remember the concept? So it will simply say all of the combination that it has. So 1 and 101, then 2, then 101, then 3, 103. Okay, then 4, 101, then 5 or 4, 102. So now here the primary key is composite primary key, both. Oh, yeah. So whenever I want to connect to this table, so I will simply connect to this one. So I will connect my order ID with order ID, this one. Okay. And I do not need to have product ID here. Not at all, because I do not need it. So I can remove it totally. That's why I have included this bridge. So I will remove it. Simple. And I just have primary key now. See, sorted 1, 2, 3, 4. Now if I just want to get all of the product IDs from database, because I need to see how many products I have ordered for order ID 4, I can connect this orders table with this order items. And here I have all of the information. Oh, yes. And here you will get all of the information. And now if any products want to see the data for any kind of, you can say, order, this can also see like which product ID was ordered by like so many orders. This is the bridge. So whenever we want to work with many to many, we just change the cardinality. So now just tell me one thing. What will be the cardinality? What will be the cardinality? Yeah, just tell me. So cardinality will change, obviously. So what will be the cardinality, or basically relationship? So let's talk about this. So relationship will become, first of all, one order can have multiple order items, like here in the order ID, because orders table will be connected to order items on order ID. So one order ID can have multiple order IDs here. It is so evident in front of you. So here I will simply say one, and not here. First of all here. So that means here I have many. Okay. This is many. And I can use 0 as well, the minimum, because for minimum we have some flexibility. We can use 0 as well or 1 as well. It works. So 0 is like a standard in the industry, but you can use 1 as well, minimum 1 order item. And here in the orders, how many order items will have the records in the order ID? So let's say 1. So there'll be only one order ID, 2 one order ID, 3 one order ID, 4 one order ID. So this will become 1. Oh, and minimum 1, maximum 1. Simple. Okay, I understood. Understood? Good. So this way, this as well. Many, then minimum 0, and here 1 and 1. This is the entire, you can say, heart of the entire thing that we have studied so far. If you understood this thing, your data modeling interviews would be so good. Obviously there are some topics left, obviously, but so far, if anyone asks you any question till here, you are good to answer anything. You can even assess yourself. Just go to LLM, just ask, hey, just ask me some data modeling concepts. Just even ask like, hey, give me some scenarios, give me some questions related to modeling. I will answer you. Simple. Because see, in the interviews, they will obviously ask you verbally. So you need to prepare for that. Simple. Make sense? Cool. So this is the core of relationships. Now, are we good to actually create this ER diagram? Because we have all the things. Ansh, Lamba, you just mentioned that we have orders table and we have products table, but we do not have any kind of connector. Very good, because I intentionally left it for this section. Because now you understood why do I have this orders table and why do I have only products table. I need to have one more entity, and that entity will be called as order items. Yes, now it's the time to create it. Let's create it together. So let me just copy and paste one entity, and I can rename it, let's say order items. And here I'll be having order item ID. Okay, order item ID. And here I can say order ID. And here I can say product ID. Cool. And price. Do I need to keep price? Not at all. Yeah, I don't need it, because price should stay in the products table, and stock quantity I do not need it. Do I need anything from orders table? Do I have quantity and all? No, so that is fine. Okay, cool. So I can even delete these two things. So let me just delete it. Where's the arrange? Okay, so cool. So this is my order items, and let's change the color as well. So perfect. So this has become the connector. Sorted so far? Very good. So now we need to pick the right relationship. Let's first of all pick the relation for customers and orders. So here you will have so many things. So here you need to just pick the right line. So we know that for the customers, there can be only one customer. Okay. And there can be multiple orders. So we need many side on the orders and one side on this customer. So let's pick the right one. And I can see it. I think this one. Yeah, I think I have found this one. Perfect. So this is my one. Cool. And this has become my many. Make sense? So this is the connection. I hope it is visible. So many side is on the orders, and it is 1 minimum. You can also have 0. It is not a big deal. It is because it is flexible thing. You can just pick 0 or 1. Both works. Okay, for ER diagram both works, but it is understood that whenever you're just doing anything on the database side, you need to just pick that thing. Okay, because I doubt if we have 0 1 as well. Yeah, you can just pick this one. It is fine. So this is the relationship for the orders. Cool. Okay, so after customers, because in order we will be having just one customer and that's it. for the payments. So now let's talk about the orders and payments. So just tell me one thing, what will be the relationship? Now obviously for every order, the payment ID will be unique. For every order, the payment ID will be different. So that means one order ID will have only one payment. Okay, one order ID. Like for one payment, there'll be just one order ID. That is for sure. That means one is on the order side. Okay, let me just bring it here. And how many payments that can we have for single order? In most of the cases, it will be one, because if you are just completing the order, you will either use, let's say, your card, whatever. But in special cases and in the real world, same customer can use multiple options to pay. How? The person can pick the card, and the person can also use a gift card along with the, you can say, vouchers and all. So your order ID, one order ID can have multiple payment IDs as well, because for each unique your order placement, your payment linked with the order, it will generate a new ID. So relationship will look like this. So let's say many on the payment side. So one order ID can have multiple payment IDs. Okay, so let's bring that one. So this is the one. So we can also copy it, and we can just put it one here and many here. Perfect. This is the flow, many to one. One payment ID can actually be linked to this one. Simple. And I'm just connecting the tables. Okay, so you can just simply say, and now you will say, Ansh Lamba, on which column you will connect this thing? What will be the foreign key? Foreign key is your order ID, because data is flowing from your child table to the parent table. Parent table is orders, child table is order ID. Make sense? Cool. So now let's configure this one, orders with shipments. So now one order can have multiple shipments. Because if we have multiple, it depends, by the way, it depends upon the implementation. Because let me just tell you, so this is the order, this is the shipment. So one order can have one shipment ID, and team can keep on changing the status of the same shipment ID. They can, if they want to make in place changes. But some organization also try to keep the history of the shipment. So for every chain, there'll be a new shipment ID. Make sense? Shipment status is, let's say, delivered, in progress, shipped, whatever. So one order can have multiple shipments. Okay, I hope it is clear. So let's say, or even if it is not the case, let's say one single order can have multiple products. So if one order can have multiple products, then it will have a different shipment ID. So let's say if you ordered iPhone 15 with charger and with, let's say, cover. So maybe your phone will come next day and your charger will come, let's say, 1 week after. So every particular product will have a different shipment ID. So one order can have multiple shipment ID. So this is also can be the case. So for sure, this will become the same way that we have just processed this thing. Perfect. And I'm just connecting this one, or let's say, so I'm not worrying about the columns because it will create a mess like lines. So I'm simply connecting the table to table. Okay, cool. Okay, makes sense. So this order ID will become my foreign key now, and this will be connected to orders. Now the main thing, what is the main thing? So now the main thing is connecting orders with products. So now if we want to connect orders with products, what exactly we need? We cannot just directly connect orders with products, not at all. We need to first connect orders with order items. And you already know the flow. The flow is one to many. Here we just have one, and here we have multiple values, right? Cool. Let's use this side. This side is free. Bro, what is okay, perfect. Let's use this side. Yeah, perfect. Let me just fix it. So yeah, that is good. Okay, so now the final products table will be mapped with this one. So let's move it a little. Perfect. So now products, same way, one product ID can have multiple product IDs here. So similarly, I can copy and paste it here, and let's say product ID, and this will have many side here. Make sense? Cool. And if we just configure the foreign key, then order ID will be my foreign key, and product ID will be my foreign key. Makes sense? Cool. Because data is flowing from the child to parent. This is our data model. Wow. This looks amazing. So far, so good. I hope so. So this is our data model, ER diagram that we have created for our requirements. Simple. So our data model is ready. Let me just paste it here because we'll be changing it. Why? There are so many concepts, bro. There's so many concepts. So let me just paste it here. This is our data model that we have created. Cool. And everything looks good with all the relationships, all the things that we have studied, right? Very good. So first of all, congratulations that you have come so far. So now the next topic that we need to learn, that we need to study in depth is normalization. First of all, normalization is actually the thing that you need to understand very well, because normalization is the area where you might see some complexity, but do not worry, I am with you, so don't worry at all. So normalization, first of all, what is normalization and what is denormalization? Normalization means you want to normalize your data. Seriously, see, let me just show you the definition. You are just laughing. Wait, what is normalization? What is database? See, database normalization is a process aimed at minimizing data redundancy, is called database normalization. This is the simplest definition. Normalization means you need to normalize the data. Normalize means you just need to make sure your data is not redundant. So that means it is self-explanatory. You do not need a special definition for it, that particular case. So it is the opposite of denormalization. Denormalization means when your data can be redundant. But in database normalization, we do not want to keep our data redundant. And you already know the pain point, why we just perform this thing, to save cost. To save cost. Remember the very first section, $350 million. So we need to normalize our data. Ansh, Lamba, well, like our data looks good. What is the requirement to normalize data? It is good, but there can be some improvements. Really, yes. So in order to perform normalization, let me just write the definition. So let's say normalization means it aims to reduce data redundancy. Simple. This is the aim. This is the aim. Now what will happen? Normalization, in the database we have some rules, or we have some types of normalization. We have first normal form, then we have second normal form, then we have third normal form. By the way, we have so many, but these are the most popular normalization forms that we have. So we have rules specified for each type of normalization. For each type we have some rules. Okay, for like our database, our table should have these rules satisfied, only then you can call it as first normal form. Your table should have these rules satisfied, only then you can just say second normal form, then third normal form. In the industry, we try to keep our tables at least till third normal form, at least. In 90% of the cases, 10% are, you can say, your exceptions, where you can compromise data redundancy with speed, because nowadays we have like strong computing engines, plus we have, let's say, cheap storage cost as well, because the same 1 terabyte of data can be stored under $100. We do not need to spend $350 million. Okay, but yeah, so we can compromise something in 10% of the cases, but in the 90% of the cases we need to achieve at least third normal form, and you need to understand how. And you know what, just to help you understand, I have added one rule here as well, where we just need to modify our existing data model, because then only you will understand it, only then. But first of all, you need to understand it as a standalone topic, only then you can apply it in the, you can say, already created data model. Okay, so let's try to understand normalization step by step. First normal form, second normal form, and then third normal form. Okay, let's actually see. So now let's talk about the very first type of normalization, or you can say the very first form of normalization, which is called first normal form. Simple. You just need to remember one thing, that these normal forms are, you can say, iterative in nature. For example, if you want to first of all achieve second normal form, you would need to first meet the criteria of first normal form. So you cannot simply say my table is either of first normal form or of second normal form or of third normal form. No. If you are saying that your table is of second normal form, that means your table is actually first normal form and second normal form both. Okay. Just remember this thing. So whenever we want to make sure that our tables are in at least first normal form, what are the rules? Rules are very simple. There should be a primary key. Let me just write it for you. Just two rules. There should be a primary key. That means each row should be uniquely identifiable. And the second rule is there shouldn't be multiple values in each column. Okay, or in any column. What does it mean? So let's say I have actually prepared a very good example. Let's discover that. Wow. So let's try to understand this thing in detail. So let's say I have a table. It's called orders table. Okay. And we need to check if this table is actually in the form of normal for first normal form or not. So this is the table. Okay. We have a primary key. Yes, 101, 102. That is very good. But what did I say? Second rule. The second rule is every column should only have one value. But if I just check the column called phones, I have two phone numbers saved. If I check the value of products, I have three products, two products, basically more than one. That means each column, each column must have atomic or single values. So that particular rule is actually not applicable here because we have multiple values. So we need to convert this table into this table where we have literally applied the, you can say, explode function that we just call it in the big data world. So I have simply opened, or basically you can say split this list, all of the multiple values. So now I have 101 order ID. Same person, Amit Sharma, has first of all two phone numbers. Okay. Then product pen, notebook, pencil. Okay. Because three products and two phone numbers, that means 3 into 2, 5. So 1101 now will have 5 records. 101, 2, 3, 4, 5. Same with 2, Neha Verma. So this will have 2 records because this person has 2 products. 1, 2. So now what are the benefits? Benefit is each column has only one single value. There are not like multiple values stored within just one column. Okay. That means no repeating groups or lists. Data is easier to manage. Simple. So first normal form means primary key and every column should have atomic values, single values. Simple rule. Yes. Simple rule. Yes. But Ansh Lamba, this table is now converted in the form of first normal form. But what is the primary key? Because primary key rule is violating. See, we have so many duplicates. You are right. You are actually right. So that is why now the primary key is not just order ID. Now it is order ID plus your product. Oh, plus phone number. So now you have composite primary key. I hope it makes sense. Okay. Now you have composite primary key. Order ID, phone, pen, then order ID, phone, whatever product, then this way. So now you cannot say like the order ID is the only primary key that you have. Whenever you are converting your unnormalized data into normalized data, yes, you might convert your single column primary key into composite primary key. Simple. Very good. So this is your first normal form. Now obviously this first normal form, okay, it is good, but still not very good in terms of normalization that we perform in the real world. That's where the concept of second normalization form come into the picture. Second normal form. So what is second normal form? First of all, the rules are very simple. Second normal form should meet all of the criteria of first normal form. This is non-negotiable because I just told you that this is a kind of iterative approach. So the table should be in the first normal form. Then there should be no partial dependency. What is this partial dependency? These are the two rules. First normal form and there should be no partial dependency. Partial dependency means when you have composite primary key in your table. That means more than one column is responsible to uniquely identify the records in your table. In that scenario, there can be a case where some columns are dependent on one portion of primary key, because here let's say we have three columns that we are using for the primary key. So there can be scenario that some columns will be dependent on one type of primary key, like among all, and some columns will be dependent on some part of the primary key, but not all of the primary key. Are you getting my point? So that's the concept of partial dependency. That means your columns can be partially dependent on the primary key, on the composite primary key. Oh, so let me just explain this concept with this particular diagram, because when you see the pictures, you actually understand it. So let's try to understand the second normal form with this example. So first of all, as we can read, must be in first normal form, and every non-key attribute must be fully dependent on the whole primary key. That means no partial dependency. Non-key attribute is a very fancy term, but this is just a column which is not a primary key. Simple. And it should be fully dependent on both the keys, or whatever number of columns do we have, okay, on all the keys. So here in this example, if I just look at this table, order ID, product ID, which is very similar to the previous example, we have simply extended with some columns and we removed the phone number. That is fine. So if we just look at this order ID and product ID, these two are the primary keys. Okay, that means composite primary key. We have product name, quantity, unit price, and customer name, right? So what is the problem here? The problem is partial dependency. That means if you just look at the columns, okay, product name depends on both, okay, quantity depends on both, okay, unit price depends on both, but this customer name is actually dependent only on the order ID. So that means customer name depends only order ID, not the whole primary key. That means it is partially dependent on the primary key and not fully dependent on primary key. Oh, makes sense. Makes sense. And this is also causing redundancy if you just closely look at it. If we just change, let's say, name of customer, if we just change the, let's say, last name of Amit, then we have to make the changes at 3 rows. So we are simply performing more, you can say, operations without the need of it. Now what we can do, we can split this table into two different tables. So we'll simply say, hey, we will create one table for order ID and customers, because customers only dependent on order ID. So this is table number 1. Second table will not have customer name and will only have those columns which are fully dependent on the primary key. Make sense? So this is your second normal form. Okay. Now this is very good, but if you would ask me, second normal form and third normal form go hand in hand. Really, yeah. Because let's talk about now third normal form, because we understood, like, we just removed the partial dependency, and that means now all the columns are, that means non-key columns are dependent fully on the primary key. That is good. Okay, so now when we just talk about the third normal form, and I am simply repeating it because this go hand in hand with second normal form. Very once you are like well versed with normalization, you can directly say, okay, just remove the partial dependency and just remove one more type of dependency. Let's talk about it. So first of all, the rules are very simple. The table should be in the second normal form and there should be no transitive dependency. Now Ansh, Lamba, what is this thing? Transitive dependency. We just remove the partial dependency. Simple, we removed it. But now what is this transitive dependency? Let me just explain with the help of an example. So this is the diagram, and do not worry. I know, like, there is so much of information written here, but do not worry. And to be honest, third normal form is the most important one. This is the most confusing one as well, but do not worry. Starting point, table should be in the second normal form. Okay, and these two are the tables that we have currently in our case. Okay, and yes, we added some more columns so that we can actually demonstrate this thing as well. Okay, now I said there should be no transitive dependency. What does it mean? That means all of the non-key columns should not be dependent on the, like, on any other column. Did you understand? Let me just explain with the help of an example. That's why I've created this example, bro. So let's say you have a table like this. Order ID and customer name. This is good. This is sorted. This is very good. This is already in the third normal form. Why? Because all of the non-key columns, here the non-key column is customer name, is fully dependent, or basically is only dependent on the primary key. Simple. Now, if I just look at this table, I will see that I have order ID, product name, okay, category name, unit price, quantity. I can see that my table, this table has all of the columns that depended on both the things. So product name dependent on primary key, that is for sure. Category ID dependent on both. But what is this category name? Category name is not dependent on the primary key. Category name is dependent on category ID. So this is called transitive dependency. See, let me just explain. So this is product name. This is dependent on primary key. Category ID dependent on primary key. Unit price dependent on these two keys. Quantity dependent on these two keys, basically primary key. But category name, this dependent on category ID. This is called transitive dependency. All the non-key columns should be only dependent on the primary key, and that's it. Oh, so category name is actually not dependent on this particular primary key. This is only dependent on category ID, and category ID is not the primary key. So this is called transitive dependency. So what we will do, we will simply break down this table into two different tables now, where we will have one table specially for category, right? Let me just tell you one simple technique as well. Like, it is not a rule, but it is a kind of, you can say, very helpful tip. Whenever you see redundant values in your table, think about like whether it is a transitive dependency or it is a partial dependency. In most of the cases, it will be partial dependency or transitive dependency. That is why I told you that the second normal form and third normal form go hand in hand, because both remove the dependencies. Both make sure that there are no redundant values in the rows. Make sense? Very good. So this is your third normal form, and I hope now this example is clear with this particular diagram, because this is a very detailed one, because I wanted to explain you with this example like this so that you can actually understand it. Because when you see it in actual tables and right from the beginning, because we started from first normal form, then second, then third, you actually understand it better. So that is why I just picked this diagram. Okay, very good. Now in my data model, we also have one, you can say, transitive dependency. Let me just tell you what is that. So let me just open my ER diagram quickly. So this is my ER diagram, right? So if I just look at one table called orders, okay, order ID is a primary key. Customer ID is dependent on obviously primary key, because we need to know which customer placed the order. Order date, total amount, everything is dependent on this. Store branch ID is also good, because we need to know from which store we got the order. But store branch name is not dependent on primary key. It is only dependent on store branch ID. Very similar to the example that we have just seen. Oh, similar to category. So we need to create one special entity for store branch name and store branch location. So that is why I intentionally added this thing, so that you can understand it. Because see, when you will be actually facing the problems, only then you will understand it, right? So that is why. So let's quickly create one ER or entity for our ER. So this will be called as, let's say, store branch, and here we can create the store branch ID, and there will be two columns, store branch name and store branch location. Now just tell me one thing, what will be the primary key? Primary key will be this store branch ID for sure, and here it will act as foreign key, right? And what will be the relationship? So there can be multiple store branch IDs, because there are like so many orders, and we can have multiple orders from the same store branch ID. So it will be like many to one. Okay, and we do not have any foreign key here. It's simple. So let me just create one many to one here. So this will be many, and here it will be, let's say, one. This is your diagram, final one. We can also change the color if we want to. Let's change it to gray or purple, not green, no, orange, no, yellow. Yeah, it's good. Or let's say gray. Okay, cool. We have more. So this is our final, you can say, ER diagram that we have created. And now it is, yes, and we need to obviously remove it from here because we do not need it. And now you can say that our data model is in the third normal form because we do not need anything else. Earlier it was not in this table, orders table was not in third normal form, but yeah, other tables are good. Other tables have followed all of the rules that we just create for first normal form, second normal form, third normal form. Cool. So this is all about your normalization. Okay, perfect. Now let's try to understand this special type of normalization form as well, which is called Boyce coord normalization form. What is this thing? Let's try to uncover this. Yes, this is also considered as the more strict version of third normalization form, and you need to understand this thing. And by the way, this normalization form will not be followed every time in the industry. It's a personal choice if you want to follow the BCNF, but till third normalization form is the standard in the industry. But still you need to understand this thing. First of all, there's a special dependency that we just remove here. It's called functional dependency. Now what does it mean? Before understanding functional dependency, you first need to understand a word called determinant. What is determinant? So whenever we compare the functional dependency, that means one column is dependent on the other column, okay, and then whatever thing is written on the left hand side, it's your determinant, and the right hand side thing is your thing, which we are actually determining. Let's try to understand with the help of an example. So let's say we have this table, and in this table we have courses, right? And each course has exactly one instructor, and each instructor teaches exactly one course. Simple. That means you are studying in a classroom, you are studying in the college, university. There is a dedicated instructor for each course or each subject. Simple. And you are the students. Perfect. So if you just look at this table looks fine. Okay. Following all of the things, let's say till third normalization form, and everything is good. But if I just look at the functional dependencies, then course is dependent on instructor, or it is determining the instructor. Course is determining the instructor, and instructor is determining the course, right? And what are the candidate keys? Candidate keys are student and course, or student and instructor, so that they can uniquely identify the record. Now the problem is course column, or basically instructor column, either of these columns is strictly, or you can say not strictly, I would say they are secretively determining the next column. So if I am saying that one instructor can only teach one course, that means when I say instructor is determining the course column, this is called functional dependency. And there's a special rule for it. Whenever we are determining any non-key column, that determinant is actually, or you can say that determinant should actually be a super key. Now just tell me one thing. When I am saying that instructor column is determining the course column, is instructor column a super key? Not at all. Not at all. Because we can see so many duplicates. So that violates this BCNF, Boyce coord normal form. So what we will do, we will simply break these two tables into two tables where we have instructor and course, and student, and then your course or instructor, whatever you just want to do. Okay, because we have determined that we will just keep student and course in one table. So we have John, Mike, and these are the courses that they have taken. But instead of also keeping the instructor column, we will create a special dedicated table for it so that it can follow the BCNF. I hope it makes sense. This is a little bit a confusing one, but it is, yes, very important, especially from the interviews point of view. Rule is simple. There should be no functional dependency. There should be no functional dependency. But again, Will you apply BCNF on all the tables every time? Not exactly, because you can pick whether you need to just pick BCNF or not, because it is your personal choice, or you can say it is actually the demands coming from the requirements side, stakeholders, whoever is designing the requirements. So you need to first of all make sure like whether you need to do this thing or not. And to be honest, when we have, let's say, storage cost cheaper and it is becoming even more cheaper day by day, we hardly perform BCNF, but I do not want to generalize this thing because there are so many organizations who prefer BCNF because they have set up their databases since decades. So it is fine. But I'm just telling you, if you're just designing a new database design, you might skip BCNF. It's still fine because you still need to achieve till third normal form, and that is it. Sorted? Very good. So we have like fourth normal form, fifth normal form, sixth normal form, but you do not need to go till that way because in the industry we just perform till BCNF. That is, you can say, the upper limit of it, but it's their personal choice. If any 1 in 1,000,000 companies wants to just build something, let's say with 6 normal form, they can. But usually we just go till BCNF and that's it. I hope it makes sense. So we have concluded like how to just perform data modeling on the OLTP side. Make sense? So this is all about your OLTP designing. So let's quickly see what exactly we have covered so far. So we have covered almost everything, yes, in the OLTP. So your OLTP is done, right from the requirements till the designing, everything is done. So now, if I just look at the layers, so logical layer is done, conceptual layer is done. Now the physical layer. Now in the physical layer, you just need to write the statements that you would have learned in your SQL, like create table, constraints, and all of these things. So now you can just actually perform this SQL task as well. Okay. Now I just want to show you, obviously like you would know how to write create statement things in SQL, and if not, you should know because SQL is like non-negotiable thing even before designing the database. And if you do not know about SQL, if you want to learn about SQL in detail, because there are two different things, one is designing and modeling and SQL queries in itself. So I have created one dedicated course on SQL as well. You can simply check it. So I can just show you SQL Ansh Lamba, and this is a very good browser as I just told you. So wow, let me just write SQL YouTube Ansh Lamba. So yeah, this is the complete course that you can just watch for SQL if you just want to master SQL queries, how to query data, especially for data domain, because data domain people should master SQL. Okay, so this is one way of creating the SQL commands. But now because we have AI as well, so I will just show you how you can just integrate AI whenever you just want to create those SQL commands. So what you can do, you can literally hand over your entire database. You can even take the snapshot of this particular data model, this one, okay, and you can hand over this image to your, let's say, ChatGPT, and you can say, hey, I have designed this particular database, could you please generate one script, SQL script for me? So let's open ChatGPT. Perfect. So this is my ChatGPT. So I'll simply paste the screenshot first of all, and now I will say, could you please, what could you, obviously it can, please generate one SQL script, let's say for MySQL. You can just pick any database because 99% the script will remain the same, but in 1% cases data types can change, so you have to determine which database you want to pick. It can be MySQL, it can be Postgre, it can be Oracle, anything, or Microsoft SQL Server. Please generate one SQL script for this ER diagram, okay, for my SQL database. That's it. You can obviously enhance some things if you just want special type of naming convention for dedicated schema. Let's say I want to create one schema called raw, and that's it, and it will also pick database. So you can just provide more and more information if you want to. Hit enter. So what it will do, it will try to read this image, and it has created this entire script. Wow. How? Because it rendered this image, it created or basically extracted the text out of it, for each table, because now this is not just an LLM, this is MLM, multimodal language model. So multimodal language model such as GPT 5.5, 5.2 as well, 5 as well. So they can just process the image as well, pixel by pixel, the same way they just perform your tokenization with the text. Obviously I'm not teaching AI here, but yeah. So now this image, it knows that all the relationships as well, like your many to one, everything. So it has created this particular table for you. Okay. And the great thing that I just love about it is it has also created the constraints. That means it has also taken care of the foreign keys as well. This is the thing that actually excites me a lot. I do not need to even tell, okay, what will be the foreign keys, what will be the relation. It automatically determined all of the relations, many to one to one to many, whatever, even the foreign key. So it literally created this entire script in just few seconds. And to be honest, if any data professional will be writing the script with the right data types, because here it would have picked the perfect data types for it. Obviously you can just review it. I'm not saying like just simply use the script. You can read the script, you can just analyze, and you can just review the script. But the point here I just want to mention is, if you would ask any data professional could take at least 1 hour to complete the script. I'm so sure about it. And if not 1 hour, at least I would say 2 to 3 hours, sometimes a full day, if the database ER diagram is big or complex. Here we have 1 2 3 4 5 6 7 tables. If let's say we have 25 or 30 tables, it is normal thing, right? So in that scenario, the person can literally take a day. Why? Writing create statement is not a you can say time taking thing, but actually adding the constraints in each table and taking care of everything is running fine. He would be testing it as well. So you need to just make sure that you are following all of the things syntactically as well. So now here this AI has literally generated the script in just few seconds, and that's it. That's why whenever someone says like AI will not replace you, but a person using AI will, this is the perfect example of it. Now you do not need to spend a whole day on just performing this thing. You literally created the script. Now you just need to spend, let's say, at least few minutes, 10 to 15 minutes to review it. If it needs any kind of modification, you can ask MLM to change it, or you can just change it on yourself because you have the technical skills as well. But you would hardly spend 30 minutes, not the entire day. Are you getting my point? Very good. So that way you can also perform or automate the entire step that we discussed, which is your physical layer. Because you do not need to write code line by line now. You just need to know the things, and that's it. Okay, so this was your physical layer that we have just seen how to create the script, and you can obviously run that script, and that's it. So this is all about your OLTP database modeling. Now let's talk about the OLAP data modeling. Okay, because now we have reached till that step, and I'm really happy that you have understood this OLTP modeling in detail, because this is your backbone. Okay, and now you need to build something even more stronger. Let's scroll. Let's now master OLAP modeling. Cool. Now after building the old OLTP modeling, okay, or you can say even if we have OLTP modeling already existing, because in most of the cases OLTP models will exist, some part of it at least. Now you would need to create the OLAP models on top of that OLTP modeling. Okay, so now what you need to do, you will simply take this design, which is your ER diagram, or not just ER diagram, actually your entire database structure. So let me just paste it here. So you will take this OLTP database and you will use this database as a source. This is your source, right? Now what will happen? Now what you need to do, you would literally perform some things, which is called how you want to see your data warehouse, or you can say OLAP model, but we also consider it as data warehouse. So now, because in the OLTP database model, we will have so much of data. We have so many tables, which might be useful for your data warehouse, which might not be. Because OLTP is just like, you can say, dumping every single piece of data. But OLAP data models are built for specific purpose. You can build a data warehouse for finance team. You can build data warehouse for operations team. You can build OLAP data model for a specific team. So it always serves a specific purpose, right? So you do not need to put all of the tables, all of the you can say source tables that you have in the OLTP data model. Not exactly. So you need to first of all figure out what exactly you need. Again, the very first layer, requirement gathering. But here the requirement gathering would take place more on the technical side, not with the business stakeholders. Yes, we would include business stakeholders who would build the reports and all, but here the technical person would just take the lead, such as data scientists, such as data analytics people, okay, analytics engineering people, or some you can say analytics managers as well, if they are using data directly, because we need to serve them. Now we need to serve them. Make sense? So now what will happen? Now we need to first of all use this source and how we perform OLAP modeling. So first of all, we take the source data and whatever data we need, whatever it can be, let's say payments data, orders, whatever. So let's say we want to use all of this data in our case. Okay, we are just taking the hypothetical example. Let's say we want to use all of the tables. So what we will do, we simply create a kind of medallion architecture in order to build any data warehouse in the modern days. So what we do, we simply take this source and we perform something called as data layering, and it is also considered as medallion architecture. So what we will do, we will simply create the very first layer, which is your raw layer, or basically bronze layer. Okay, I'm just explaining this concept from the modern practices point of view. Okay, so this is your bronze layer. Now this bronze layer, what this bronze layer will do, this bronze layer will literally dump all of your data that you have in the OLTP database. Okay, and it will simply create a replica of your source without performing any kind of modifications, or you can say transformations. Okay, here what do we have? If I just look at the data, here I have, let's say let's take this. So here I have payments, right? Here I have orders, here I have shipments, and so on. Here I have shipments and so on. Okay, so this way I will just take all of the sources that I need for my data warehouse. So this is my bronze layer. Bronze layer means dumping the data without anything. Dumping, simple. Okay, just take the data, dump it. Take the data, dump it. Take the data, dump it. But we do not simply dump this data directly. We dump this data incrementally. That means, let's say for the initial run, you dumped all of the orders data. Cool. Next day, you got, let's say 1,000 plus orders. Now you will not just dump again the whole data. It will be so much of data and it will be so expensive to dump it, right? So what you will do, you will only incrementally load the 1,000 records. This is your incremental data loading, right? We build pipelines for performing incremental loading, but currently we are understanding the data modeling part. Okay, but that's how we do. We do not directly perform data modeling on the OLTP. Not at all. Not at all. Understand the concept, bro. So incrementally load the data into the bronze layer. Okay, but in the as it is form, we incrementally load the data, but we do not touch anything. We do not change anything because we consider this as our replica of source. Cool. And how often we perform this thing? It depends on your you can say ingestion architecture. If you are processing data in batches, then it can be, let's say, on a daily basis. If you are frequently loading your data, it can be in hourly basis. If you are processing your data in real time, it can be in, let's say, seconds as well. It depends what type of architecture you are following. Kappa architecture, and there are like so many architectures. Okay, but that is something on the data architecture side. Currently we are focusing on the data modeling side. But yes, that's why there are like so many branches that we data engineers need to consider before actually building the final data warehouse. Okay, yeah, I know Lambda architecture is very popular nowadays, but yeah. So this is incremental data loading. Then what we do, we build something called as silver layer. because now we have the layer names as in the form of medals. That is why we call it as medallion architecture. What is so special in the silver layer? In the silver layer, the data will be in the transformed manner. Data will be transformed. It will not be just replica of dumps. No, it will be transformed. Okay. And data will also be aggregated here. A very good practice in the industry that we follow is OBT, one big table for silver layer. Okay. OBT, one big table, where we simply combine all of the tables, all of the columns, and we simply create only one single table with all of the columns, one big table. OBT. This has become more popular more recently, but earlier people were simply curating their data, or basically enriching their data and transforming their data, and they were just dumping data in the silver layer. But now we have started joining our data as well, because we have now good compute that can actually process the data faster. Make sense? So we simply combine all of the data that is required for our data model, OBT, because it is actually seen as very performant. Plus computes are becoming inexpensive day by day. That is why. But earlier, before OBT, people were literally, you can say, modifying their data and performing transformations on top of their data, and they were simply storing it in the silver. But now we perform OBT. Once our OBT table is ready, then we simply break down this one big table into the form of small tables, which is called gold layer. And here we perform data modeling. What kind of data modeling? It is a special kind of data modeling called dimensional data modeling. Oh, it is very different from your normalization. Okay, it is dimensional data model. This is a special type of data modeling. What is so special here? Here the special thing is we create data model, yes, but that data model is not normalized, it is denormalized. Okay, do not worry, we're gonna just understand this thing in very much detail, but first of all try to understand the vibe. So first of all, the data model will have two major things: facts and dimensions. So your tables will either be of these two types, facts and dimensions. Okay, you will either have a fact table and dimension table. Now what is this fact table and dimension table? So first of all, if we just look at this data model, here we do not have fact or dimension, here we just have a table, simple. But when we create the dimensional data model, we create either fact table or dimension table. Okay. And Ansh, Lamba, you also said that your data will not be in the normalized form. Exactly. So here we have data in the normalized form, right? All of the normalization form, first, second, third, and that BCNF as well. But here we do not need to perform normalization. Ansh, Lamba, why? Why? You said that normalization is important to reduce redundancy, to reduce blah, 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 blah. You said that, but now you are saying that it is not important. Why? Because we do not need to care about data redundancy here. We need to care about speed. We do not need to care about cost here. We just need to care about the data size. Because on the OLTP side, we need to immediately store the transaction. Okay, and transaction will be just one. Here, we need to query data including millions of rows, billions of rows. We do not care about, you can say, your storage cost. We just do care about the data retrieval, and that's it. We do care about the performance of our reports. When a manager clicks on any particular filter, any kind of dragger, the report should be refreshed immediately. We cannot say, hey, wait, we have just built the normalized data model and it will take some time. Not at all. And whenever we have normalized data model, it will include so many joins. We cannot afford that. It will take a lot of time. So that is why we do not normalize our data. We denormalize our data, but still we have a kind of data model. Okay, dimensional data model. Now what is so special in this fact and dimension? Let's talk about it, and let's talk about what is a fact table and dimension table. Then we will just build one entire fact and dimension table as well, like fact and dimension tables as well, using this particular, you can say, your structure. Okay, let's talk about it. So now let's talk about, first of all, the dimension tables. Let's try to understand this thing. Dimension table. Now whenever we just talk about dimension table, we need to consider that we are talking about the context. This is the only word that you need to, or you can say, remember or understand, whatever. If you understood this thing, dimension tables are done. Context. Dimension tables are context focused, and one good thing about data modeling in the OLAP side, rules are not actually followed. To be honest, we just need to take care of the context as per our needs. Let me just explain, don't worry. Context, what do I mean by context? So I want to create a table for a specific context. If I look at my sources, if I just, even not, I'm just looking at the source in detail. Okay, I'm just looking at from, let's say, 10,000 feet. So I know that there can be a context for products. There can be a context for customers. So what exactly I am doing here? I am finding the context, or there's a very specific word that I personally like. It is not written in the book, first of all, so do not find it. Theme. Dimension tables are theme focused. So you need to create a table focused on the theme called products. So you would need a dedicated table for products where you will store all of the information related to products, but contextual information. What is this contextual information? Contextual information means where you are simply providing the context, nothing else. Context means all of the textual data. Product name, category name, all of these things. We do not store any kind of numbers which are aggregatable. So no numbers are allowed. And here when we just talk about numbers, we are not talking about those numbers which are stored in IDs. We are talking about numbers that can be aggregated. Numbers aggregate table. Or let's say aggregated. So if we can just aggregate a number, then we cannot store that information in the dimension table. For example, we have a column called price. Do we aggregate the price column? Do we find total, average, max, min? Do we? Then we cannot store this column. Do we find sum of product ID? Do we find average of product ID? No. So even this product ID is in the integer form, but this is not considered as aggregatable column. Make sense? Okay. So we just store the context in the dimension table and we create each table for each context. Okay, there will be a dedicated table for each context. Simple. Very good. So this is all about dimension table. What is the use of dimension table? The use of dimension table is just to provide context. To whom? To fact table. Okay. Fact table. Okay. So here we create the fact table. Now what is a fact table? Just the opposite of dimension table. Here we do not need to store the context, we just need to store the numbers that we can aggregate. Numbers that can be aggregated. Oh, because we do not need any kind of context, we simply need the facts. Facts means numbers. Price, quantity, any numbers you can just imagine right now. Okay, any numbers which can be aggregated. Okay, shipment amount, order amount, all of these, amount, price, all of these things, months, any numbers which can be aggregated. So fact table is for numbers, dimension table tables are for context. That is why this is a very standard. Whenever we build the data model for the OLAP, we create fewer fact tables because we store all of the numbers in just one table. And yes, fact tables are also focused on a dedicated data model. Usually we have one fact table and multiple dimension tables, but I would say it is not, you can say, a very generic rule. We can have multiple fact tables and multiple dimension tables as well. But if you want to understand, let's say we have just one fact table. And in order to demonstrate this thing, there will be just one fact table. That's it. When do we have multiple fact tables? For example, let's say you are also considering the scenarios for cancelled orders. So you cannot store that information in the same fact table, because one fact table is for one purpose, one goal. Second fact table is for second goal. So fact tables are goal specific, or you can say, yeah, you can say goal specific, like what exactly you want to achieve with that fact table. Sometimes they are also domain specific, sometimes. Okay, so we have this fact table, and the standard is, let's say, one fact table in the middle, and we create multiple dimension tables around it, like this. So these will be the dimension tables. Oh, okay. Makes sense? And they will flow like this. So this is a very, very, very common data model that you would see in the OLAP side. Okay. Simple. Fact, dimension, dimension, and each dimension is providing a separate and dedicated context. Let's say this is dim customer, this is dim products, this is dim shipments, this is dim payments, all of the dimensions providing a dedicated, you can say, your context. And these tables are not normalized, these tables are denormalized. You can just store redundant values, it's allowed. You just need to be theme specific. So let's say in your products table, here, if you have category ID, even if you have, let's say, category name, if you have, let's say, category, subcategory, whatever, if you follow the normalization rules, you would have different tables, right? But if you follow the dimension data modeling rules, you can just store categories and subcategories as well in your product table. It's fine. It's fine. It's completely fine. It's allowed. Because you need denormalized data and you prefer performance over the storage cost. And storage cost is not very expensive, because now we just work with data lakes and lakehouse architecture. It is very, very cheap. Very cheap. We do not even worry about data redundancy. Okay, not even 1%. Okay, so this is your fact table and dimension table. Very high level overview. Now let's talk about the types of it, because yes, we have types of data models, or you can say OLAP data models, or I would say types of schemas. So here we have two different types of architectures. One is star schema. The second one is snowflake schema. Oh, cool names, but very easy thing. Let's try to see what is star schema. This example is a star schema, and this is the simplest schema that you would create. Schema here does not mean the schema of your database. Schema here refers to the design, the model itself. Okay, so this is star schema because it is in the shape of star. I don't know, like if you just add, let's say, one more here, it would look like in the shape of star, let's say, like this. That is why it is considered as star schema, and this is the most simplest, most straightforward one. Very easy to make, very easy to maintain, everything is fine. We have one more type of schema or model, which is called snowflake schema, which is a little bit complex to maintain, but yes, we have that thing as well. Let me explain that as well. So what is so special in snowflake schema? So in the snowflake schema, it will be like this, but there will be a special case. The special case is this one. Let's say you have the dimension tables and you have one more dimension table, let's say here, which is dependent on this dimension table. Oh, like this. This becomes your snowflake part. This becomes your snowflake part, and that's why we consider it as snowflake schema. If you would have seen the snowflake, like snowflake, not the snowflake technology, snowflake like icon, it has like those little branches right in the center. I will just show you, don't worry. So this part becomes your snowflake. See, that is why it is considered as snowflake schema, where the dimension is not directly attached to the fact table, it is attached to the dimension table itself. Okay, if you would ask me, yes, we have the solutions in the industry which use snowflake schema as well, but If you would ask me for the modern solutions, we rarely create Snowflake schema because we do not need to create Snowflake schemas anymore, because we do not worry about the storage cost. We worry more about the performance. And obviously when we are just creating Snowflake schemas, performance degrades most of the time, not every time, most of the time, because you would need to create multiple joins and all, right? So this is the standard star schema right now, but yeah, Snowflake schema is the thing that you should know. Cool. Now on Lamba, this thing is clear conceptually, to be honest. Let's create one data model so that we can understand better. Okay, let's do it. So let's try to create the data model for this. Okay, and if we want to just create the data model, we first need to convert this thing in the one big table format, right? Like one big table. So let me just write the one big table here for this particular table. Okay, let me just do it. So this data model, when we will be just applying OBT, that means one big table, this entire data model, and I have just rectified that there is a relationship missing. So let me just add that as well. Maybe it was removed. So we also need to connect this order items with orders. When I was just building OBT, I was like, where's the connection with orders with order items? I was like, whoa. So let's do that as well. So let's create one relation with this as well. Let's say with order ID. With order ID, and this will be connected with this one, with this, which is order ID. Perfect. So this is also connected. Okay, order items, and let's add one column more here, one or two column more. So I just want to add one column, which is, let's say, quantity and the price, or line item price, line amount, like on which amount it has just purchased it. Let's say line amount. Simple. These two columns are like obviously optional. It depends like what you need to just keep in your order items. So I just want to keep some more columns because I just want to create a fact table that you can just relate to it more, so that you will have some more and more, you can say, columns available, because currently we do not have much numeric columns available, or you can say measures available for our fact table. So that's why I'm just adding 1 to 2 columns more. Okay, just optional thing, or you can just ignore it, don't worry. So let's use the latest snippet. Okay, and you can just correct it in our above scenario as well if you have just used that one, so that is also good. So let's move and paste here. Perfect. So this is our data model, and when I just apply join and when I just see the end result, then this will have this big table with all of these columns: order item ID, product ID, blah 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 blah. So these are the columns, and these are all of the sources for our tables. Okay, so this is called one big table, and I know now this one big table will further be reduced to data model. Okay, so this will further be reduced to data model. Makes sense? So this is your OBT. Now this OBT will be broken down into the dimensions. So let's say star schema. Let's build the star schema. So now you need to first of all get the you can say context. So let's start with customers, because we just had a word around customers and products. Let's start with customers. So I can see that if I just go to the customers theme, I can find some context related to customers only, and this is that particular context. I have first name, last name, email, and all of that information. See, all of that information. Can I create a dedicated table which can provide context for customers only? The answer is yes, right? So what I will do, I will create a table for customers. Let's create one. So let's say this is our customers table, dim customers. Okay, dim customers. And this will have these columns: first name, last name, email, phone number, date join, and it will also have the customer ID. Okay, it will also have customer ID. Makes sense. So this is our very first table that we just then we can just create. Then after creating this table, then can I create one table with products context? Yes, but this table is very special. Let me just talk about it. So if I just look at products table, product information, if I just try to fetch the products information, I can see that I have product name, category ID, price as well, Ansh Lamba or stock quantity. Ansh Lamba, why are you just picking numbers? You said we just pick the context, only the contextual or textual data. Here, price and stock quantity are not your aggregatable numbers because this is the price of that product only. This is not providing any information like how much did you spend on the order. That's why I added this column here, because the information about the orders we will get from the order items table, not from the products table. This is just for the context of the product, like product name, let's say pen, it costs around, let's say 10 bucks. That's it. It is not telling anything about the amount that we have spent on the order. Make sense? Okay, cool. So this is that particular thing. Then let's create first of all this table. So I have one table called dim products. Okay, makes sense. So what columns do I have? These 1 2 3 4 columns. Enough? Yeah. And then product ID, obviously. ID will be always there. Okay, just simply ignore ID. ID will always be there. Or let me just create that as well for you. So let's say customer ID will be with the red color, and then we have product ID with green color. These colors are very important, bro. Perfect. So now, can we create one dimension table for branch? Can we? Yes, because we have some information or context for branch as well. So I will create one table for store branch, or you can say branch. Cool. Okay, let's create that. So one table will become store branch, or you can say dim branch. And always remember that we always create dimensions first. We cannot create fact table first. So this will become my dim branch. Cool. And this is a blue color. Perfect. So now I can also color this thing store branch ID. This will also stay there. Yes, we store IDs in the dimensions. Now, what else is left? Can we create one for payments? Very good. So what exactly I will keep in payments? Just tell me this thing. You have the answer. Will we pick payment method? Is it a context? Yes, very good. Payment amount. Is it actually a context? Not at all. This is a measure. This is an aggregatable. So we will not pick payment amount. We will only pick payment method. Okay. And we will pick payment status and transaction status. These two. Wow. I hope now you are understanding this thing, right? Very good. So I can just pick obviously payment ID. Okay. So this is your payments dimension. Cool. Very good. So now let's create one for payments. Dim payments. Perfect. Now just tell me one thing. Can I have one more dimension for shipments? Yes. Carrier, tracking number, status, and delivery date. All are context. So let's create one for this one as well. Let's use this color. Okay. And obviously the ID, shipment ID. Perfect. Sorted. So one for this one as well. So this is called dimension and then shipment. Perfect. Now, last, can we have anything for orders? Let's see what do we have in orders. We have IDs, that is fine. We have order date. Oh, so can we just create one dimension for date? Yes. So we usually create one dedicated dimension for date, like with where we have like all the kinds of date functions like month, year, timestamp, everything. So this will become my dim date. And let's use this color. Yeah, or purple. So this will become my dim date, but we can actually store everything in the fact as well for order date, but ideally we should not. So we will simply create dim date. Okay, so all of the dimensions are ready. So now what is left? Now the left, let me just mark this as well because this is done. So now what is left? Only fact table, order ID, very good. Then we have total amount that will go in the fact table, payment amount that will go in the fact table, and then obviously the two new columns that we just created here. quantity and line item, that will also go in the fact table. Okay, because that is coming from the order item side, order items table. So this is all about your fact table. So let's create the fact table. Let's keep the fact table in the middle and let's use circle for it. Perfect. Let's use complete white, or this is also good. This is called, let's say, fact sales or fact orders. So this is your dimensional data model, or you can say star schema, for your OLTP database that we have just used. Wow. This is your fact table and dimension tables. Cool. Very good. Did you understand what did we do right now? So we simply took this OBT, like very big table, and then we simply created the, you can say, dimension tables and fact tables. Now you can say one thing, Ansh, Lamba, how are we going to connect this dimension table with fact table? Like, what is the joining key? Remember this ID? These are the joining keys, because whenever we create the fact table, we also keep these IDs as well. So all of the IDs will be stored inside your fact table as well, inside your fact table. Okay. But in some cases, people prefer creating the surrogate key. Now, Anshlamba, what is surrogate key? Surrogate key is actually not a rule. Surrogate key is basically the replacement for your regular order ID or any kind of ID. So for example, let's say you have order ID. So in reality, order ID can have, let's say, this much of big value. It is so normal. Whenever you just place the order, you get the ID. But it is not very convenient to apply the joins on this big ID. So what we do, we simply create a replacement for this ID. We simply say 1. Simple. Then for the next value, we simply say 2. So this is like auto increment ID that we create, but the idea is same. Even without surrogate keys, you can just work with the IDs as well. It's fine. Okay, but in the industry, we just use surrogate keys. But it is not something that you have to use. It is again a design thing. Just for the feasibility and readability, you cannot have those long IDs in your fact table. Cool. Very good. So we join our fact table with dimension tables on top of either IDs or surrogate keys if we have picked surrogate keys as a solution. Make sense? So what we did, we simply broke down this one big table that we joined after OLTP, and then we simply created dimensions first. We cannot create fact table first, and the dimension tables, we always pick the context. And context can have string and numeric value both. We just need to understand whether we can perform aggregations on top of that or not. Simple. Okay. And a very good example is product that we just discussed. So if we just look at product that we just picked, so in the products, we do have numeric column, price and stock quantity, but these are just the context for product. This is not context for your, or you can say this is not something that we can just apply aggregation on. We need to apply aggregation on these two values, quantity for the order and line amount, because this is stock quantity, inventory. Okay, this is the quantity that is actually ordered. Let's say how many mobile phones did you order? 2, 3, 4, 5, whatever. Line amount, how much amount did you pay actually? Because sometimes the same product is available, let's say for $100 off, it depends. So what exactly the amount you paid? So this is that particular thing. Make sense? This is just a generic price that you have just fixed in your database. This is not the price that you might have picked in your, let's say, order. Simple. Okay, cool. So this is all about your dimensional data model, or you can say OLAP data model that we just built. Makes sense. Now let's talk about a very important concept within this data model. Yes, and this is the most complex part, but it is very simple. Let's talk about it, and it is called types of dimension tables. Now we have just talked about fact table, dimension table, but you know what? We do not just create static tables for dimensions. What do we mean? Dimension tables do change with time. Okay, and that's why we have a concept called slowly changing dimensions. Okay, now what are these things? Slowly changing dimensions. So for example, let's say you have a dimension called customers. Now today the name of the customer is, let's say, whatever. Okay, now after a month the surname is changed. So how would you tackle those things? How? So you have different strategies for it. You have different options available. And the very popular, you can say, options available that we have is type 0. Yeah, we have SCD type 0, SCD type 1, SCD type 2, SCD type 3, all of these kinds of types, similar to normalization form 1, 2, 3. So first of all, type 0. This is everyone's favorite. Type 0 says there are no changes. Dimension will never change, which is not actually true in reality, but there are some dimensions which will never change. For example, date of birth. That is a different scenario where you just put a wrong date of birth, but date of birth will not change actually, right? And there are like so many things which will never change, kind of. If it is not a typo, that is a different story. But if we just talk about from the context point of view, there are some things which will never change, right? So those dimensions are called type 0, and these are like very rare dimensions. So you will simply say no changes. Perfect. But in real life, most of the time we get our dimensions changed. So this is type 1. Now what is this type 1 SCD? And I want to explain this concept with the help of a Wikipedia, and they have actually used a very nice table that I personally like. Whenever I just need to talk about SCDs, I simply open that Wikipedia table. That's it. Not to read anything which is written on the web page, just for the table. Just for the table. Let me just open slowly changing dimensions Wikipedia. I hope this is the one. Yeah. So type 0, you understood, right? Retain original, no changes. For example, date of birth, original credit score, whatever. Now type 1 is also called as override, or I call it as upsert. Now what is this thing upsert? For example, let's say there is a customer, or not a customer, let's say supplier. Okay, so here the supplier key is 123, code is ABC, supplier name is this, supplier state is California. Okay, after some time the same supplier with the same key, same code, same name change the state. It is very simple, you can say scenario, it can happen. So in those scenarios, you can have the value, new value, you can have the new value. Now in type 1, if you want to build a slowly changing dimension type 1, you can override this value, or you can upsert this value. What is upsert? Upsert means update plus insert. That means when you just create type 1 SCD, new values will be inserted, that is sorted, but the updated, the already existing values will be updated, which is in this case. So here the same record will be updated in place. As you can see, California state is changed to Illinois. I think it is in the South America. I think so. Yeah. So California to Illinois. I think so. IL in USA. Yeah, Illinois. Midwestern US state known for blah blah blah. Okay. So this is the one. So let's say the supplier state is changed, Illinois. Okay. Here we simply made the in place changes. We literally updated the record. Wow, yes. This is called type 1. Simple. And this is the most simplest slowly changing dimension that you can just maintain. Very simple. And yes, in the industry, we use type 1 a lot. So this is absurd. Let me just write. Okay, makes sense. And I'm not just pasting any screenshot, because you can simply go to the website and everything is there. Now type 2, which is my favorite and a little bit complex, but do not worry. Type 2 means you need to retain the history. Now if I just ask you one thing, okay, that supplier changed the state from California to Illinois. You made the in place changes, but what if I want to know its previous state? Then you cannot answer the question. In that scenario, you have to just maintain the history. That's where the type 2 comes into the picture. So when we have type 2, we simply retain the history by adding the new record. Wow, yes. So here what we do, we simply add a new record, okay? But we simply create a version so that we will have at least and understanding that this was the previous version and this is the new version. Oh, but a lot of companies, lot of organizations do not create a version column. It is not very good. We simply create the start date and end date column. What does it mean? So let's say you have this record and you will have a start date, which is like very, you can say initial date on which the record was inserted, and end date will be very big date by default. This date will be, let's say, like this. 19, not 19, like 9999 0101. This will be your date, end date by default. That means this date is not changed. Some companies prefer keeping it as null as well, so that it is never ended. I do not like nulls in my data, so I simply put this type of date. That means date is not ended, but still it is like very big date. Sorted? So what will happen? Now let's say we have a new record. So we will insert the value and we will just make this record expired, because end date is this one. And this will become the new record as start date is this one and end date is null, or you can also pick 9999, whatever. Okay, 0101. Simple. So this way you can actually retain the history. Now if you want to ask a question like what was its previous state, or what was the state when it placed the order for this particular between this date, so you have the answer. Simple. Very good. This is your SCD type 2, and this is my personal favorite. You can just retain the history. Now there is one more type 3, which I haven't used much, and obviously you should know what is this thing even if you do not use it. So here you simply add a new column. Why? Add a new column to store only the previous value. Here you do not retain the entire history, but here you just retain the, you can say, one previous history. So let's try to read the type 3 as well, and add new attribute, or you can say add new column. So this method tracks changes using separate columns and preserves limited history, not entire history, just limited history. So what it will do, it will simply create a new column with the original value. So here if you just look at it, it will simply use this value, and what it will do, it will simply create one column called current supplier state. So this is the current state, but it also has the previous state available. Let's say next time this state is changed to, let's say, LA, let's say, okay, or let's say NJ, New Jersey, whatever. Then you will simply keep IL in the original supplier state, and then new will be here. It depends like how you just want to design it. Some people just try to keep the very first value as the original, and they just keep on changing the current one. Some people just try to move the, you can say, values to one previous value. It depends. But here we do not track all of the history. Simple. But in most of the cases, you will just store the previous history. Only the previous history is stored. Okay, makes sense. This is not very helpful because I don't know what difference it will create if you just have one previous history. Either you should have all the history or you should not have any history. There's nothing in the middle, but yeah, some people prefer it. So this is another type of, you can say, SCD that we have. Cool. Very good. Now in the industry, again, we just use till type 3. Yes. So you do not need to know about type 4, type 5, type 6, but there are some, you can say, techniques, but I haven't seen any solution in the data engineering so far to use type 5, type 6, all of these high level types, because it is very easy to discuss these types in paper. And when you actually build those types with billions of records, you will actually see like how hard it is to maintain those. Okay. So type 4 is their add history table, where they simply create a dedicated history table. Not a very practical thing, I would say. If you just want to create a history, I would simply go with type 2 instead of type 4. This is, I don't know who created this. Is usually referred to as using history. So what they do is they simply create they have simply combined type 1 and type 2. If you would simply closely look at it. So this is your main table, type 1, and you also have the history. Yeah. But if you have the history, you can simply query this table. Why you need to have both? Okay. And then type 5 is, you can say, builds on type 4 mini dimension by embedding a current profile. And then they have type 6 combined approach. So they have literally combined 1, 2, and 3 all. So redundancy, maintainability, all of these things are there, but I do not need to just worry about these things. Type 0, type 1, type 2, type 3 are good. So this is all about slowly changing dimension. Do you know what? If you understood slowly changing dimensions, even from the conceptual point of view, you can actually answer all of the questions in the interviews confidently, easily. And now you will say, Ansh Lamba, how to implement slowly changing dimensions? There are multiple techniques. Obviously, if you're using PySpark, you can just write the code in PySpark or Spark SQL. And if you are just performing everything using SQL, then yes, you can just use merge statements, which is very similar to absurd. So that is also one of the options that you have. If you're using Snowflake, then obviously you can just explore Snowflake ways of doing the things. But I personally like using with Apache Spark and PySpark. So I just prefer using with Databricks and some tools like DBT, which has already automated entire thing. So yeah, this is all about your slowly changing dimensions. And I would say this is almost everything that you need to know from the modeling point of view of the OLAP or data warehousing. Now, yes, data warehousing is actually a big topic in itself where we talk about, remember, these layers in detail, like how to create these layers, incremental, bronze, silver, and how to perform ETL, ELT. But here we discussed only the gold layer, which is the dimensional data modeling. But when we just talk about OLAP modeling, we need to talk about data warehousing as a separate topic. But from the modeling point of view, you are good. You are good. But if you are excited or curious to know data warehousing in deep, then you can also learn data warehousing. Not a big deal. I can just show you the video. I think I have one course on data warehousing where we have talked more on the data warehousing side. So you can simply search data warehouse. You can just search something like this and you will just find it in YouTube. I don't want to search it in the web page and then scroll. Simply go on YouTube and search this thing. You will get the video and you can just watch it. Okay, so this is all about your data modeling. Everything you need to know in the data domain, especially. I hope you liked the video and you have literally learned so much actually. And if you just found this video helpful and if you just want to help others, simply hit the like button and share this video with your friends, and happy learning.